Okay, here. All done. We're recording. All right. Well, we'll still, yeah, I think we'll still maybe give like a few more minutes though for people to trickle in, and maybe I'll just also make sure I can share my screen. Okay. If everyone can see my screen, all right.
Good.
Yeah.
Okay. Awesome. Let's see. Just I want to be able to see the participant list. Okay. Cool. All right. Yeah, I see. Still, some people are still arriving. All right. Maybe I should also ask, while we have everyone here, was everyone who wants to follow along, were they able to get the Rhino plugin installed on their machines? Or
Yeah.
does anybody have any questions about that? Yeah. So just making sure, if you do want to follow along, because there'll be at least maybe like 5 or 10 minutes of presentation, and you have Rhino installed in your machine, you just have to go to pollination.cloud and to our Rhino plugin page, and there's a button here to download a single click installer for the Rhino plugin. So this will take you there. You may have to, if you don't have an account already, you may have to first create a Pollination account. But once you've done that, make sure that you download the Rhino one, because I know a bunch of people, like in every workshop I thought there's somebody who downloads the Grasshopper one by accident, but we're working with the Rhino one today. And if you're one of those people who've used up your free trial and you need a license for today, just send me your Pollination account handle. So mine is, if you see me, I'm if I go to, like, let's say my apps, you'll see my account handle is Chris W. Mackey. If you send me that, I can make sure I give you like a add you to a license pool for the workshop.
Yeah, so if you send it as a message, we can help with that.
Yeah, send it as a message either on Slack or in the
email,
chat here. Like, yeah. Yeah. But that's basically it. If you want to be able to follow along, you just need to run the single click installer and have Rhino installed. So yeah, let's see. We're still getting a couple more people trickling in. I mean, maybe I'll just make this full screen. Maybe we'll just give it one more minute and then we'll start. Does anybody have any questions, at least on the installation, if they want to follow along? Okay. All right. Well, we're 5 minutes in now, so thank you all for coming into the workshop on the Pollination Rhino plugin. And to give you guys like a bit of a sense of what we're going to be covering in the workshop, at least in the 3 hours or so. So I'm going to give you like a short introduction, at least to, I mean, this may be a lot of like refresher for those of you who were in the morning workshop on the Pollination Revit plugin. But I'm just going to give a kind of overview of Ladybug tools versus Pollination, because we're going to kind of be straddling the line between those two today a bit, working both with the Ladybug tools Grasshopper plugin, but mostly with the Pollination Rhino plugin. And then we're going to try a few different workflows of building a model in the Pollination Rhino plugin. We're going to build a model from scratch, tracing over plans, which is kind of probably, if any of you are energy models on this in this workshop, you probably know that's one of the most common ways that people build models these days. But with the Rhino plugin, we have really robust ways of also building models from 3D geometry. If you have that already mocked up in Rhino and you just want to convert it into something that's simulatable, we'll go over workflows for that. And then the kind of holy grail of workflows that we'd really recommend for building larger models is cleaning up exported design models. And for this one, we're going to work from a model that was exported from the Revit plugin. It's actually the same sample file that Mustafa worked with this morning, exported from there. And we're going to clean it up and basically turn it into something that is fully simulatable and that we could actually use to inform design of a building. So we're going to cover that. Those will be the main sort of model creation workflows. Then we'll show you a little bit of QA/QC tools about how to check the various properties of the model. We'll maybe tweaks and change a few of those. And then we're just going to spend the rest of the last third of the workshop kind of just going over integration workflows. So we'll actually import that model we built with the Pollination Rhino plugin into Grasshopper, show some capabilities with Ladybug tools. Once you have that clean pollination model, all that you can do with it in Ladybug tools. We'll show you some integration with the Pollination Cloud computing service. So when I say pollination here, I mean specifically the cloud service. And we'll actually run a daylight simulation on the cloud. Everyone will get the chance to do that. And then lastly, I'll give a presentation because Mustafa covered a lot of stuff about interoperability with other energy modeling tools. I mean, I'll show you some slides related to that, but we'll kind of go through that relatively quickly at the end here. So that's the outline for today. We're going to be like going up a learning curve as we go through each one of these steps. But to give you first an introduction, at least to explain, because we get this question a lot, like what is Ladybug Tools versus Pollination? What is the difference between those two? And along those lines is the question of what is open source and free versus what is our commercial product. So anything that we call Ladybug Tools, that is our open source project. And that mainly refers to either the Python SDK of our core libraries or the free Ladybug Tools Grasshopper plugin that many of you are familiar with. Whereas Pollination is the banner under which we sell a lot of our products and services. So that includes the Revit plugin that some of you may have seen this morning if you're in the workshop with Mustafa. It includes the Rhino plugin that we're going to be working with today. It includes our cloud service and App Store, and I'll go into some detail with that. But that is really the main distinction between these two, that we'll use the word Pollination to refer to any of the products that we sell. So Ladybug Tools, many of you may already know, is just a collection of insects, each of which is a plugin that does different capabilities. The ones we'll be working with today when we do bring our pollination model and do some analysis with Ladybug Tools, we'll be using both Ladybug and Honeybee and not really getting into the other insects, but we'll be using those to run some various simulations with our model here. But just to say kind of what the values that Ladybug Tools was developed with. So, I mean, all of Ladybug Tools, those core libraries and that Grasshopper plugin is open source. It's all pretty much written in Python for the most part. We did that largely because we believe that, you know, you need the freedom to be able to adjust any of the inputs that are going into your simulation models to make them useful. Right, and all those assumptions should be visible and editable to you. And for similar reasons, right, we did not build our own simulation engines with Ladybug Tools. We simply built out connections to other scientifically validated engines like Energy Plus, Open Studio, Radiance, and UrbanOpt, which is an urban scale energy modeling interface. We built connections to these rather than trying to remake the things ourselves, because those scientifically validated engines were built with consensus. They're also open source, right? And for that reason, you have the freedom to really change and edit the things that go into them. And then lastly, we believe in freedom and flexibility. There should be no barriers to making your simulations more accurate. You should never hit a paywall or feel like, you know, you need to do something to make something more accurate or a better representation of your product. Right, and largely because we stuck to those values with Ladybug Tools, it's, you know, the Grasshopper plugin has been downloaded over 500,000 times. Our forum has over 3,000 monthly active users. Every day we're getting, I mean, almost every hour you see, we get like a new topic posted to that forum, and the forum gets about 6,000 page views per day. So this gives you a sense, at least the scale of the community around Ladybug Tools, which has matured a lot over the last 10 years since it was first started. So that kind of refers to the open source project that underlies both the Ladybug Tools Grasshopper plugin and a lot of the capabilities that we're going to be working with in the Pollination Rhino plugin today. But the banner of Pollination is, as I said, what we sell all our products under. And if we had to describe what Pollination is, it is an ecosystem of tools for environmental modeling and building simulation. And so this includes, it is not limited, but includes things like the collaboration platform of our Pollination Cloud, which we're going to work with at the end of today. It includes the CAD and BIM plugins. So it includes the Rhino plugin we're working with today, as well as the Revit plugin we worked with this morning. It is an app store, which we will touch on briefly. And those of you this morning may have seen Mustafa use some of the apps. Apps are in beta, I should say. We're continuing to develop them, but that is the vision for what we want to offer with Pollination. And then lastly, it's a cloud computing service that allows you to run simulations at scale, not just for speed, but also for better shareability of the actual logic and execution of your workflows. So that's Pollination. And to give you kind of overview, this is again maybe a review from this morning for those of you who have seen it, but the Pollination ecosystem, right? It consists of these cloud versus desktop halves of the ecosystem, right? And then cloud side, we have things like cloud computing, an app repository, a recipe repository, and interfaces for those, for interacting with those. On the desktop side, we have plugins for Rhino, Revit, and Grasshopper. The Grasshopper one being the free one that you may have seen me show earlier. And then the thing that is meant to bring this all together that I said is still in beta are these apps. Right, and so basically what we're mostly going to be working with in this workshop is these connections, basically mostly from the Rhino plugin to some of these other desktop file formats and desktop softwares, as well as the connection to Ladybug tools from Rhino and Revit. But this is, interlinked with all the rest of the ecosystem that you see here through the magic of APIs. But that kind of gives you a sense of at least like the overview of our pollination ecosystem. So, all right, now that you guys got an introduction, at least an understanding of like, the different parts of our of what we're going to be working with today, I want you guys to actually, those of you who want to follow along, can open up Rhino right now. And we'll just do a check to make sure that everybody who wants to follow along has gotten it installed correctly. So if you have Rhino installed and you've successfully run that single-click installer that you can get again from, if you need that, by going to this app.pollination cloud CAD plugins. Again, you want to download this Rhino one in the middle, and maybe I'll just paste this into a chat just in case anybody wants to get it at the last minute. There's a 14-day free trial for the Pollination Rhino plugin, but if you've used that up, just let us know in the chat or on Slack, and we can add you to a license pool for the workshop. Okay, so if you have successfully installed it, you should, you may see a pollination tab over here on the side if everything's working correctly. The other thing that you can do to make sure that it's installed correctly is go to PO License Manager, just type this command into the Rhino toolbar. And what this will do, this will tell you, well, one, if you don't have a valid license checked out already, it'll say that your license isn't valid yet. You could use this basically to either grab the license from a license pool if you're using that from us, or if you have your free trial license, you can also manage it through here. Does anybody, I guess I'm imagining a lot of people may have something that says like this, that your license is expired and they just need to get a new one. And so if this is the case, when you type that PO License Manager command, all that you have to do is sign in. So just click the please sign in. It'll bring you to a web browser where, in this case, I'm just going to sign in with my own Ladybug Tools account. And then once you're done, it should say hi, and then your username or that sort of handle, that pollination account handle, right? And it'll still say your license expired until you try and retrieve a license. And once you do that, in this case, sorry, we have different license pools for different workshops, but I'm just pulling it from the Ladybug Tools license pool. But after you've done that, after you retrieve the license, it should say that it's valid, and then you're good to go for the workshop. Does anybody need to see any part of that again, or have any questions about getting your license activated? Okay. And I think everyone's on mute by default. So if you, okay, good. I see some thumbs up in the participant list. Awesome. All right. Well, yeah, and feel free to interrupt me at any point. There's, this is an informal workshop. So yeah, any questions that you have on what we're doing, just please feel free to ask any questions as we do that. So, all right. So once you have a valid license, you should be able to see maybe a pollination tab over here on the side. If you don't have that, if it looks, I guess, maybe something like this, you may need to bring up a thing on the side. I usually do that by just typing layer. And then if you don't, and I typically keep that on the side there. And if you aren't seeing the pollination window here for any reason, you can just click on this little gear for options, and there should be a checkbox for pollination here. Yeah, if you've installed pollination correctly. And you just want to make sure you have that checked so that you can see, basically, this is the UI, the interface from which we're going to be interacting and creating a lot of our energy model geometry here. So yeah, just let me know, raise your hand or speak up if you have any issues getting the pollination tab to show up here. All right. So the other thing, hopefully, that everybody got an email that had the link to the shared Google Drive that we're using for this. So we're going to be starting from a design plan, basically, of a model here. So we're just going to spend like the first hour or so basically building up a model from scratch of this single family home, of which we already have a 3DM Rhino file here. So if you guys can go and download this file, or if you've copied it to this shared Google Drive folder to your own Google Drive, all that you have to do is just go and open that 3DM file. So I'm just going to go to File, Open here, and I'm going to find the 0 single family home file. So I know there are other files in here, but this is the critical one that we're going to be working from today. And if you go and select Open on this file, you should see it's got a little floor plan of a very simple single family home, which also happens to be, I mean, this I use this model a lot, but this house belongs to my mother-in-law, but we're going to model it as if it's, build a fully detailed model of this. So I've enlisted you all in basically making an energy model of my my mother-in-law's house for an energy retrofit. All right. So once you guys have this, right, you can see you can go over to the layers window, and right, we have actually a few different like groups of layers here. So the one that we're mostly seeing right now is this 2D plan layer. I can turn that off to turn off basically the whole thing that we're seeing in the scene here. We also have like a little 2D elevation basically of one of the elevations of the house here with some, some windows on them. And then we also have a fully detailed 3D model. We're not going to be working with these other layers yet, but we're going to get to them, get to incorporating them so we can give you a sense at least of the different workflows of modeling from scratch. But I'm sure a lot of you, yeah, if you've energy modeled in the past, probably your workflows that you get some sort of plan like this in a DWG or PDF format, and you want to just basically convert this, you want to trace over this 2D plan in order to make an energy model. So that's what we're going to start off with today. We're just going to try and trace over this basically and build a fully detailed energy model using the Pollination Rhino plugin. So, all right, any questions getting the Rhino file? Everyone's got it open. Who wants to follow along?
Yep.
Awesome. Okay. All right. So the first thing that you guys will see, if you go over to the Pollination tab, so there are a few different buttons here basically for adding various geometry elements to your model here. So we have things like adding rooms, adding opaque faces, adding apertures, which is basically our word for windows basically, or skylights, or basically anything that will let light in. We have doors and we have shades. So usually when you're building an energy model, the very basic unit of it is a room. So we're going to start by just trying to draw a room basically in our Rhino scene here. So if you left click on this little add rooms button, and you'll see that there are a few different ways that you can create rooms. So you can select some actual detailed geometries, which we'll get to in a second. You can select geometries by layer, or we can do this last one, which is drawing a room. So that's what we're going to do right now. If you guys simply then click on draw a room, you'll see it's going to show up with your little cursor is going to change. And you can simply click anywhere in the scene and then, click a second point and basically draw a box very simply this way, right? And so this is the most basic way that you can draw. Like if you're just making a shoebox, you can do this with 2 clicks just like this. You see, as soon as you're done, you've actually created this room object here. And if you hit this little drop down, right, we have different faces that compose this room, right? We have 6 different faces for 4 walls, a roof, and a floor. Right, so you can see whenever you use this draw room command, it'll basically allow you to draw a box like this. And certainly, right, our house is a box, so we probably could, try and get this to work for this case, but there's actually another way of drawing rooms that's going to be better suited, at least to our case, where we have something off axis like this, right, that's not perfectly aligned to the XY axis of the Rhino scene here. So I'm going to just take this, I'm going to delete this room that I just drew right here. And you'll see once you click it, left click it, hit delete, it'll delete itself from the actual tree menu as well at the same time. And I'm going to go back. I'm going to go to add rooms again, select draw room. But this time you'll see that there are actually a few different options we have on this command when we draw a room. So by default, it's using this 3-point one, or it's kind of more like 2-point because we're just doing 2 corners of the room and then automatically assigning a height to that. So instead of using this, we're going to use this freeform option here, which is going to allow us to basically trace, whatever we want in 2D plan. And that'll be a much more amenable to our case here where we don't have a box that's perfectly aligned to the XY axis. So you can simply left click on this little freeform button, and that's going to change the whole menu here basically. And now what you'll be able to find is once it's switched over to that freeform mode, you can go and click on the endpoints basically, snapping to the endpoints here and clicking the corners here to draw out and basically trace out a room around the whole building here. And when you're done, you can simply hit enter, or if you go back around to the same point, I think, yeah, it'll know to basically build a whole room like that. One thing that you guys may not have by default, if this is the first time that you're opening Rhino, here, I'm actually going to do this again. I'm going to delete the room and show you guys again, is that if you guys go to add the room, you say draw a room and you want to make sure you have freeform selected. But if you guys notice that we can snap to the endpoint, this, if you've worked with Rhino a lot, this is probably second nature. But if this is one of the first times you're working in Rhino, you guys may not have this snapping to the endpoint here. And the way that you can get it to snap to the endpoint is in the lower left. There are a few different things to turn off different types of snaps. So for example, right, if I only want to snap to the endpoint, right, I can just make sure that only end is checked and it's going to snap to the end here. If I want to snap to end and near, you see near allows you to go along the curve in addition to snapping to the very end point. And Rhino's pretty good about telling you exactly what you're snapping to. I mean, the important thing to have for now for the workshop is make sure you have end selected so that you can actually easily snap to these different corners of the actual plan that we have here instead of just trying to blindly trace it. And that'll at least make sure that the model that you're making is a good representation of the actual real building that we have here, right? Instead of just trying to eyeball it and potentially getting off a little bit from the plan. All right, so hopefully everybody was able to get at least, once you're done with this, once you've traced all the way around the outside of the house, you should be able to get a box like this. Does anybody need to see that again?
No, I have one quick question. So it only the pollination works with meters again?
So pollination, we work with any unit system. Well, I should say almost any unit system. So it's meters, millimeters, centimeters, feet, or inches. You can work as, any of those systems are acceptable. And we automatically take care of, the fact that Energy Plus only works in meters, we just take care of that conversion when we translate it to Energy Plus. Okay. So yeah, so you can work in whatever system you want. And we know that that's pretty important. But yeah, I mean, that's a good question because historically we had only supported the native Energy Plus units of meters, but now you can do whatever you want.
Right.
And I think is this one, I have to see what units we're working in here. Yeah, this one is in meters, but you'll see later in the workshop, we'll use a Rhino model that's in feet. So you'll get at least a sense of like both unit systems.
Got it.
Yeah. Any other questions? Okay, I know I'm going slow here also, like especially I'm sure if people are proficient in Rhino, a lot of this is redundant, but we're gonna be going steadily up a learning curve here. So yeah, don't worry, everyone's gonna get to hit their limit at some point in the workshop. All right, so you guys would see, right? So we basically know that we've drawn a room, which is a box, right? It's a closed solid. This is the kind of fundamental unit out of which we create pollination energy models and indoor daylight models as well, right? Out of which we create our building models. But one thing you may not have realized is that when we created this box, there's a lot of intelligence built into how the plugin decides what these individual faces of the box mean. So if you guys actually look in the very upper left corner of the pollination tab here, you'll see there's this little button called color by face type. If you click on this, you'll see that it's going to color the faces of your room here that we've drawn with a color that basically represents what type of face that is. So you can see that walls get this kind of yellowish color by default. Roofs get this like red clay tile color. And surfaces that are in contact with the ground, like floor slabs, get this kind of brownish color that we see here, right? So by default, the pollination plugin knows, what should be a roof versus wall versus floor based on, the orientation of these various different faces in the model here. But of course, right, we see off the bat that we don't have any windows assigned to our box right now, right? That this is just basically a single, six-sided room in this case. So the next thing that we're going to be doing is we're going to be actually trying to draw some windows with this. And if you left click on this little color by face type again, it'll turn that preview off so that we can then start to see, right, that we actually have windows in our plan view here. And we have a front door here as well. So what we're going to be doing now is we're actually going to be trying to trace and essentially draw out these windows from the plan. Using the plan as a guide, we want to draw them onto this box-shaped room that we've created here. So moving down kind of the list of what we have here, the next thing that we're going to do, we're going to click on this, left click on this little add apertures button, right? And as I said earlier, apertures is just our fancier term for windows or anything that lets light into the building. So if you guys left click on add apertures, you'll see again, just like rooms, there are a few different ways of adding apertures to a model. You can select geometries, which we'll go through in a second. You could add apertures by a window to wall ratio. Actually, you know, why don't I show you this actually right now? Because this is oftentimes a very useful feature in early design when you don't have any windows yet. What you can do is simply click on this add apertures by window to wall ratio, and it'll first ask you to select rooms or walls or you know, orphan faces basically to add apertures to. In this case, I can just click on the edge of the room, right? It will show that room being selected. If you hit enter, then right, well, at that point it had options for different glazing ratios based on north, south, east, or west. But you'll see, right, it's added windows based on that ratio. I think in this case it was 40%. And if you were to turn the color by face type back on, right, you'll see that these have actually been added as window geometries, and that windows get this kind of light blue color in this case. Right, so maybe just, you know, I'm not going to keep these windows. I'm mostly just trying to show you the workflow so you guys get a sense of it here. So I'm going to hit Control Z to undo that right now. But all, you know, this is a very useful way. Like if you, let's say, want to add apertures by window to wall ratio, we'll select the room. And then you, let's say, for example, you want to change the, you know, make less of a glazing ratio on the east. You can change that to 0.2 and west maybe, because those tend to be, you know, worse orientations for having lots of windows, right? You tend to want to minimize the glass on there so that you don't get so much sun, low angle sun streaming through those windows, especially in summer. Right, and so you can actually control through this menu, right, different properties. You can select to subdivide the windows if you want, in which case you'll see now if I hit enter, right, it's actually going to give you a series of windows instead of just a singular window. And on the east and west, I guess in this case, facades, we've gotten, you know, a 20% glazing ratio as opposed to the north and south where we got these 40% glazing ratios. So there's a lot that you can do with that. We try to make it very easy to start. Even if you don't have any windows yet in your model, you can very quickly generate them this way. But of course, as I said, right, we actually have, in this case, we do have real windows. So let me go, I'm going to turn the preview back off on this color by face type by just left clicking it again. And I hit Control Z to undo all that generation of windows by ratio.
Chris, sorry,
Yeah.
Can I just ask, is that if like you Control Z to get rid of them, but if you were sort of deeper into the modeling, do you have to then just delete them all at surface level? Is that the way to go?
So yeah, so another way, if I do Control Y here, if you want to delete all these apertures, what you can do, so all the pollination commands start with a PO underscore. So this kind of shows you everything that you can do with the pollination plugin. These are all commands that get added when you install a pollination plugin. And we have a bunch of commands that do selection. So there's a PO Cell Apertures here. Here we go, PO Cell Apertures. And you'll see by default, this will automatically select all the apertures in the model. If, you know, what you can do is you can show and hide the various rooms that you care about. If you hide them, if you don't want to delete those apertures. But right, once you have all those apertures selected, you can just hit delete. And that's another way to get rid of them.
So it's selections based on what is visually showing in the render window.
Yes,
so to speak.
yeah, exactly, right? Because
Okay.
if I, for example, had this, you know, I can select this room and say hide, and then if I go to PO Cell Apertures, it won't select anything, right? Because it says, you know, because there's nothing there. Right, so yeah, so you can show and hide various things basically to be able to turn off your selection capability. I mean, there are also lots of different ways to select things. I don't know if Mingbo, if you had any suggestions too of like how, I mean, maybe actually one thing to show you is that you could always select things in the tree menu too, if you want to get individual apertures that way. Yeah, is there anything else I'm missing, Mingbo?
Oh, probably if you want to select a specific window, you can inside the 3D view, you can double click the room.
Yeah.
And just go inside the in editing mode, right?
Yeah, so you'll see us use this a lot over the course of today, but yeah, if you double click on the edge of the room, so if I double click like this, you'll see it, you enter a mode where you're editing just the objects that are tied to that room and no other room that's in the model. I mean, in this case, there's only one, so it's not as clear, but once you're in this mode, you can go and select individual windows and say like, I just want to delete these two, right? And just delete those. And you know, when you're done, right after you've deleted all the windows that you don't care about anymore, right, you just can double click this again to exit it. Right, so you have lots of different ways of selecting depending on whether you want to select everything in the model or just select some things connected to certain rooms, or you want to dive down and individually delete individual apertures. There are a range of ways of doing it.
That's
Um,
great. Thanks.
It might make sense to just quickly mention the room selection mode that you can switch. Because sometimes you want to do aperture between several rooms, so you can.
By room select, I mean, do you mean like when we double click, or what do
No,
you mean
no,
by
if
room
you go
selection?
out, maybe me looking out.
Yeah,
It's the sign next to the settings of this
The random
up.
settings.
left.
this one.
No, one more left. One more
Yeah.
left. Okay.
Room selection. Ah, okay.
So if you click on this, then you
can-
get the same selection ability for the room, but now you can do it like for several rooms at the same time. I mean, this is just use it when you want to do this kind of edits, because when you're in this mode, if you move the room, the apertures are not going to move with the room because the selection mode is
Right,
separate.
yeah, because if I do this right, yeah, we don't get any
Right.
apertures moving them. Whereas if you have room selection on, which I'd say everyone following along, maybe you can, well, you can leave it on, but right, if I do this, then the apertures come with the room. Yeah, yeah, you're right. That's a really useful feature. Yeah, I mean, there are lots of different selection tools. Yeah, we could spend like a whole 20 minutes covering just those, but we'll try and use them all like as we build the models. There are lots of different like workflows we're going to show you for making models like this. So, all right, I'm gonna hit very easily, just hit Control Z though, just to bring it back to like our simple box here, because we have actually, right, we have the plan here, so we want to trace detailed windows from this plan. So instead of generating windows by a wall ratio in this case, what we're gonna do, when we left click on Add Apertures, we can go to Draw Apertures, right? This is similar to Draw Rooms, right, where we're gonna be able to snap to different things and select what we want to draw. So in this case, right, you still have to select what rooms or faces you want to draw the apertures on. And so normally, right, there's actually only one face at a time that you draw on. So in this case, if I click on, let's say I just want to draw these two windows that I know are on this wall here. If I go and I click on the edge here, right, you'll see I can select different room surfaces on which I want to draw these apertures. Just make sure that you have this one selected, right, for the wall face here. And then what that'll do is once you have that selected, I guess actually you could do multiple ones of, no, well, it's easiest, I think, if you do them at once. But you'll see by default the mode, let me see, the mode, let's make sure that it's floor plan. Is this right, Mingmo? But the default, I think, should be floor plan. And so as long as that mode is floor plan, what we can do now is once you have that wall selected, we can go and simply draw, using our snaps here, draw along the wall surface. Oh, I guess this actually, I had the different, I had elevation plan selected.
Yeah.
So probably what I should do, let me just exit out of this. I'll just hit escape for a second, is I'll redo this draw apertures command. So draw apertures, I'll make sure that I have this wall surface selected, and then make sure that the mode is, it's not elevation plan. It should be, if it says, the mode should say floor plan. Okay, the mode equals floor plan. So once you have that, which I think is the default, and you hit enter, right, you should just be able to, in this case, draw an aperture onto the face like this. And we can do the same thing for this other window here. And you see, like, as we're doing this, there are actually different options for changing the sill height, the height of the windows. And we do have, like, you'll see we will eventually get to the actual detailed window geometries in this case. But for this case, right, just using the defaults of a sill height of 90 centimeters and a window height of 120 centimeters, I think that's fine for this case. The important thing I want you guys to do is, like, once you've actually traced over those two lines to draw these windows on this wall face here, you hit enter, right, and you'll see now the windows are actually showing up as geometry. And if I were to turn back on this color by face type, right, you can see that we now actually have windows drawn onto the face here that were coming from that floor plan in this case. Right, so this draw by floor plan, it's probably the workflow that I'm sure a lot of you, if you've been, created energy models in the past, right, you get a floor plan from the architect, and you just want to trace over it basically very quickly, right, assuming that all the windows have a certain sill height and and an absolute height. Right, so I mean, if we want to, let's say, we'll draw this window next on the south here, and we'll let me turn off this this color by face type here, and I'll at least show you. We'll draw it with a different, like, sill height and window height in this case. So let me again left click on draw apertures. In this case, we'll select this wall here, this room surface, and hit enter. And in this case, right, if I want to change the sill height, we can change it to something lower, like 0.4 in this case. And then I can click on the height here and change this to something like 2.4. Sounds good enough, right? And so now when I go to draw a window, basically to trace over this part, you'll see, right, those dimensions, 2.4. Oh, no, okay, that was right. This is looking good enough, right? I can draw a window basically that's at those dimensions. It's much more like a picture window in this case, right? As opposed to these other ones that had the smaller sill height and smaller absolute height. And once I hit enter, right now that window is going to be part of the room, right? We can see, if I turn on the preview like this, right, that we have a window that we've drawn on here off of the plan. So this floor plan way is definitely one way of drawing apertures very quickly, right? You can imagine you can easily trace over all your room geometries, trace over the window sills like this. Sometimes though, right, if you have like a much more detailed facade with different shapes of windows all over the facade, maybe this simply tracing from the plan method may not really cut it. So if you see in this case, right, we actually have, as I showed you earlier, this 2D elevation for this wall over here, right? And you can imagine, right, if you get a few elevation drawings, you can orient these into your Rhino model here. And so you can just as easily draw apertures using the elevation as a guide, just like what you do with the plan. So with this on, make sure that you've turned on this 2D elevation line, and I'm going to show you, at least we're going to draw using the elevation as a guide, these windows onto this facade here. So in order to do this, right, we'll go back over to pollination, and I'm going to go to draw apertures again, right? Left click on this little aperture plus button, say draw apertures. But this time, right, I want to change the mode. Before I draw anything, I'm going to change it from floor plan over to elevation plan, right? So you should see mode equals elevation plan here. And then what you can do is you can go and select this room surface, right, that we're going to draw the windows onto. And once you've got that selected, you can hit enter. And this will bring up your cursor that you're drawing onto this wall surface. Right, and so what we can do, because we're snapping to the endpoints, I can snap to the endpoint of this window here and simply trace a 2 points for the outline of this rectangular window in this case. And that's going to add it as a window to the face. I could do the same for this window over here, just trace on top of it, snapping to the endpoints, right? And I can go down the whole elevation and basically map out the windows this way, right? And once you've traced over all the windows, right, clicking one corner and then the other corner, you can just hit enter, right? And you can see now we've drawn all these windows onto our room using the elevation as a guide. So this draw apertures workflow, right, because you end up selecting a face for it, it'll always, make sure that whatever you're drawing is on that face itself, so that you can imagine, right, if you're managing geometry of your own, you kind of have to make sure that it's always coplanar, but when you use these draw commands, it kind of snaps to everything for you. So, all right, so hopefully at least, we've been covering this, that you guys mostly got a sense of how to, draw things from scratch in the plugin here. But we're actually going to kind of leave this for the time being, because I want to show you at least another workflow of trying to take the actual raw geometry that we have without any energy properties assigned to it, and we can simply just convert that into a pollination model that's ready to go for any energy or radiance simulation. But before we do that, does anybody have any last questions, at least on how to draw or trace over plans or elevations from what I've showed you here? Okay. All right. Well, then, yeah, just let me know if anything pops into your mind. Feel free to interrupt at any point, because, yeah, you guys were asking good questions before. All right. So to kind of go back and redo this from scratch, or at least redo this with the actual detailed 3D geometry.
Hey,
For now,
Chris, I have a question.
Yeah, go ahead.
It's kind of a general question on your nomenclature. So I see like there's a room ID, and I've always been kind of confused about how you handle the faces and the kind of the subfaces. Is there any reason why it can't draw on the subfaces can't draw on kind of the host room to make it more clear of kind of the face that you're editing or you're selecting?
By draw on the room, you mean not just an individual face of the room, but
just for example, like let's say we're using a process where we're doing a full pollination ecosystem and I'm pulling in room information from Revit. I just find that all of the subfaces are not really human readable. I mean, it doesn't pull on if it's Office 101. It doesn't say Office in the faces. It's just kind of a
Yeah,
know.
yeah. So I know by default we tend to try and pull the IDs from like elements within the Revit model, which I mean the good thing about that is that you'll see at a later point is that allows you to always match things back at later stages of design if you want to pull in things from that model. If you get to like a point though where you're like, all right, just give me some like clean readable names, there is a command that we have called reset identifier. And maybe, you know, I'll use it now for this case because we're about to delete this anyway. And I mean, actually, all these IDs were auto-generated anyway, so there's nothing really sacred about them. But you can use this PO reset identifier command. What this will do is it allows you to, based on a logic, basically, you can say that you want to generate a new ID for the rooms that's based on, you know, well, in this case, right, you can generate the face names from the room name, I believe, right? Is Mingbo, if I'm correct, if I set face to yes in this command. So I guess maybe what I should do for as an example here, right? Suppose I call this, you know, I change the name of the room to be, let's say in this case, mother-in-law's house. I mean, we can, the name can be whatever we want, but right. So
Yeah.
suppose I have like, you know, I do this because this is my mother-in-law's house, right? Suppose you want the names of these faces to all be set based on the names of the room here. If you do PO reset identifier.
The faces ID won't be changed.
So the face,
So
if
if
you
you-
set face to yes.
If
So
you
that means use the display name for the face to set the ID. Sorry, I mean, but like you had to,
Oh, I see what you mean. Yeah.
yeah.
So I see.
So
So I mean,
I think
yeah.
what Victor is asking is like a better default name generation. So
Mhm.
instead of saying like, you know, randomness, so if there is a way
If you-
to just like make the display
Chris,
name.
can you double click one of the face, see what's the ID for the current?
For this, I mean, yeah.
So
you can
right
see-
now it says room.
Room name,
The
yes.
first part is room ID and then dot face ID, which is the right.
yeah.
That
Yeah,
that
it's
tells you what that faces belongs to that room. Room
Okay.
CB 663, right?
Yeah, right. I mean, and so I mean, let me just make sure I understand then what does happen if you set right, if you say that you want to reset the identifier on this based on maybe reset identifier, right? So if you do set face to yes and then you want to do it by display name, I guess in this case,
Mm-hmm.
right? And we go and then select this and hit enter.
Enter.
Yeah, I mean, I guess, yeah, right. There are things like, there are reasons why we don't do this by default and why we generate unique IDs, because it tends to make sure that things are always simulatable. So when you take the IDs into your own hands, you need to make sure that, you know, you may need to resolve adjacencies to make sure all the IDs align. But right, if I just say yes right now, right, and it will even validate the model for you when we do this, right? It'll say, okay, I guess now, well, I guess it generated the ID from the mother-in-law's house. Yeah, like you said, right? So now the ID is actually mother-in-law house. But it didn't. Yeah, I guess the thing is, if you label this like north wall or something, I don't know. Right, and then you'd use the reset identifier command. Yeah, I see. So, I mean, yeah, we could probably definitely, we can maybe put in some workflows that give you better defaults.
Yeah, I
for
can see
this.
there could be a unique ID in the background. I'm just saying as like the interface
Right.
level for troubleshooting, for visualization, to just check, do I have apertures that I want on, like you just had here, northeast, southwest, so by direction. I just could see, and I've kind of experienced wanting
Right.
it to be a little bit more
We can
clear.
have a better routine just to make sure, like for the Revit side, we have a limitation because not everything is named. You know, like we have a name for the room, but then we can use that to name all the faces. Yeah, that's definitely a very doable routine to rename. And as I say these days, like that can be an app. But like, yeah.
Yeah, it could be an app, or you can do it in Grasshopper, to be honest. I'll show
Right,
you how
yeah,
to like
right.
take the model in Grasshopper and you can reset all the IDs in there if you wanted. Like, yeah, there are many ways to actually do this, but yeah, I mean, I hear what you're saying. Better defaults would probably just have to save you from doing that. All right, well, I mean, in any case, yeah, at least, I mean, are there any other questions, at least on the drawing workflows at all? Okay. Because maybe one other thing that I'll just show you guys, right? So we've been looking at face types here before we go and delete this, right? That, which basically means, is it a roof? Is it a wall? Is it a floor? Is it a window? But we also have this other property that basically all face geometries have within our pollination models, called the boundary condition. And so if you were to turn this on, this is meant to kind of color the objects with basically what are they in contact with. So by default, everything that's in contact with the outdoors gets this blue color, and everything that's in contact with the ground will get this brown color. And so you see, by default, the command kind of knew to put this make this house a slab on grade in this case. But this is going to come back because I want you guys to be aware, as we turn full 3D geometry into a simulatable pollination model, right? We're going to have to check this again, because these assumptions, I want you at least to get an appreciation for how we come up with these assumptions and why this was in contact with the ground as opposed to being in contact with the outdoors. So, all right, now that you've got the sense of the draw workflows and at least of what coloring by faces and boundary conditions, I'm just going to select this and delete it, select the room. And we can probably at this point turn off all of the 2D plan stuff. Right, turn off the 2D plan and turn off the 2D elevation, and we'll turn on this 3D model that we have here. Right, so this is, in this case, right, if you already have your model geometry as a set of closed solids, you can also turn that into a Pollination Rhino model. Maybe just to kind of go through the kind of anatomy of how our models are structured here, because I'm sure you've gotten at least a little bit of sense of this as we were drawing the models earlier. But if I were to go back, where's my presentation here? Let me just pull up the presentation. All right, so if we look at basically how our models are structured in Honeybee, there are 5 main objects that comprise the geometry of our Honeybee models. And there's really no other objects basically outside, no other geometry objects outside of these 5. Right, so the one that we're very familiar with right now is rooms, right? Room is kind of the coarsest level that you can work with in a Honeybee and in the pollination scheme, right? And rooms are essentially just closed volumes that represent a specific usage of of a space, right? And rooms are composed of individual faces, right? So faces are things like floors, walls, roofs. They could even be air boundaries or air walls. Right, so these, the faces basically define the room. They together make a closed solid. Those individual faces can have apertures within them, right? So that's what we were doing, drawing apertures right now. They were subfaces basically to those faces, right? They're completely bounded by it. Doors behave very similarly. We didn't assign doors previously, but we'll do that now as we create this 3D geometry. And lastly, we have shade that can be assigned anywhere to any of these objects, or it could actually just be completely on its own as an orphaned object without any room or aperture that's actually shading or assigned to. Right, so these 5 objects, this is really all that you need to know. You master these 5 objects, you've got the basic understanding of a pollination model. And to kind of give you like a diagram of what a typical model may look like, right? Your model may be composed of multiple rooms. Previously, right, we just drew that one room, but as we have the 3D geometry in Rhino right now, you'll see that we actually have individual closed solids for each room that we're going to turn into model rooms, into pollination model rooms. Right, but so those rooms then are composed of faces, right? Individual faces, one for each wall, roof, and floor. And then some of those faces can have apertures assigned to them, or they can have doors, or they can have both in this case. And then shades go everywhere, basically, right? Shades can either be assigned to individual apertures, assigned to faces. They can be assigned to room as like furniture, or balcony, maybe it's assigned to a room, or they can just be context shade like a tree or a neighboring building or something like that. Right, so this gives you like just an overview of at least how you can structure your geometry to make sure that it's good to go for this. There are kind of 5 rules that we say, like 5 golden rules that govern this geometry, these 5 geometry objects. So if you learn the kind of promise that we make with these, you learn these 5 rules, you obey these 5 rules, we take care of any other, idiosyncrasies that any simulation has, like Energy Plus has tons of idiosyncratic rules about like the geometry. But in Honeybee, you only need to follow these 5 things. So first, everything must be planar. And that's kind of just a limitation we inherit from the geometry engine. So before you create your Honeybee energy rooms, you can planarize them. right? You could, basically the meshing process is something that helps you planarize them. We have lots of things to help you planarize curved geometries, but when they get into honeybee and pollination world, they need to be planar. Second is that the geometries must not be self-intersecting. You really don't have to worry about this in Rhino because Rhino doesn't really let you make like bow tie shaped B-reps. So this one is this is mostly for geometry coming in from other interfaces. Third, all the children's subfaces, right, those apertures and doors, they have to be coplanar with their parent face and lie completely within its boundary. We saw, right, as we were drawing those, it took care of those rooms automatically, but you'll see right in the model that I gave you in that 3D geometry, right, that we have these apertures ready to go as 3D surfaces that are coplanar with the walls of the building. All right, so you need to make sure that that's the case when you're building your models. Lastly, second to last, all the adjacent object pairs have to have matching areas. So this one you actually don't even need to worry too much about because we have a command that will take care of that automatically for you. So we'll come back to this one as we start to build our model. But the very last of the 5 golden geometry rooms is that the rooms have to be closed solid. So no open rooms. And the reason for that is that you can't calculate the room volume, right? If there's a hole in it, if there's an opening in it. So again, these are the 5 rules. You just follow these rules. When you're setting up your geometry, you'll be able to easily convert it into a pollination model without too much difficulty. So, all right, let's go back to our model here, to our single family home model. And we have things that are basically already following those rules, right? I said these are all closed polyfaces, ready to go, closed Rhino B-reps. And so what I'm going to do is instead of going to draw a room right now, I'll go over to this pollination tab. I'm going to click on the add rooms, but this time instead of saying draw a room, I'm going to do this select geometries. Or actually, you know what, better yet, I'll do this select by layers because I have all the rooms, basically all those closed polyfaces on a single layer. So I go select by layers, right? This nice UI comes up that allows you to, basically which layers that are on. Wow, it even hides the off layers. This is nice. So, right, so I can just say I just want this rooms layer, and then you can say convert, and then it should be able to, yeah, you can see that it turned each one of those objects into a room, and it'll tell you done, and then you can close. And I guess I can see that, yeah, I guess it gives the name of, it generates the name from the layer name. If you had done this, I guess by other means, it would have generated a unique ID, but actually maybe this is kind of nicer that it generated it from the name. Of course, right, if you start getting into it and you want to like label this one to be, you can call this one like living room or something else. Right, you can actually, get deeper into actually labeling these things with something much more meaningful. But for now, maybe we'll just leave the defaults. I just want you guys to be aware of at least that you can change the names of these individual rooms. Right, and we can actually see that by default, right, because we left on this color by boundary conditions. As soon as it converted into room, you can see what ended up happening to our rooms here, right? So, like the command was smart enough to figure out that we wanted this ground surface to be, actually in contact with the ground, to be a slab on grade. But that wasn't really necessarily magic, right? What it was is that we basically have a rule that by default, anything that is at the Rhino origin or below it becomes underground. So for example, if you knew that this actually wasn't a house that was in contact with the ground slab, but instead was, let's say, let's say it was up on stilts or something like that, right? Like I don't know, like I know in coastal areas, a lot of times you need to put the house on stilts or something so that it, the waves can go underneath it in a storm. So let's say it was a house like that. All that you'd have to do basically in order to change that, I just hit Control-Z to make these no longer rooms. But what we can do is, right, if I go to add rooms and I say select geometry, or actually before I do that, right, let me just take all these rooms together here. I'm just going to click on the layer, select objects, and you don't need to worry about following along in this part. I'm just kind of demonstrating to you how we come up with these defaults. Right, so I'm just going to move this vertically a little bit such that it's now off of the plane of the Rhino origin, such that when I now go to say add rooms and select geometries, right, and I just hit enter, right, you'll see that this ground face is no longer in contact with the ground, and that's because it's lifted off of the Rhino origin here, right? This world, basically this plane that defines the world Rhino origin. Like we can say just as easily, right, if we wanted to make sure that all these rooms are underground, like this was a bunker or something like that, what we could do, we can select these geometries, and I'll move them all to be, kind of close to being below ground. I think maybe I needed to do it a little more, but let me see. If I select these objects and then I go to kind of create the rooms, select geometries and hit enter. I guess we have to make sure that they're completely below the Rhino origin to do this. So, I mean, yeah, I'm mostly just making sure that you're aware of, that it's not magic, right? And so if you end up with a case where these boundary conditions are not what you'd expected, you may need to, move things around in relation to the Rhino origin or post-process them to reset the boundary conditions, and which I can show you in a second, right?
Sorry, I have a question. So how does that work if your one room is, let's say, lower than, like, a portion of your building is lower than other? Then does that actually understand the different, like, level of below grade?
So I guess, yeah, I mean, so the default is like a completely flat, assumption of a flat ground surface. So yeah, so part of your building is below the Rhino origin and another part is above the Rhino origin. Those parts that are below will get, by default, get a ground boundary condition, while those that are above it will get the outdoor boundary condition. I mean, you could always go through and change it, right? So yeah, so if I wanted, I could probably turn off room selection, maybe select all these faces, and then I can go to PO, or actually I can probably just either click I can go to PO, edit face properties. And I can change the individual boundary conditions of those faces, or it says no faces.
You have to do Control-Shift to select the face.
To select the
Now you
faces,
have
that's
the
right.
rooms, right?
Okay, yeah, I
maybe
think
you
this
just
one
select one. If you do Control-Shift and click on one.
Right. So,
Yeah.
okay. Yeah. In this case, right. If I can now go to edit face properties, say,
I
okay,
see.
and I can change that. I mean, it's a sandwich in between two ground pieces. So I don't know how realistic this is, but right. Yeah. You can see, you can go through and edit it, but I just want you to be aware of how the defaults come to be, because especially if you're, just preparing your geometry before making a model, right. Being aware of that Rhino model origin is helpful.
Got it.
So I'm going to
So
go,
for
I'm
some-
going to, yeah, go
for
ahead.
some cases, if you have like slope, like they are partially the same wall, partially on the ground and partially it's like above, you can always split that wall into two pieces and then manually convert that, like
Got
the
it.
small, like bottom piece to the ground boundary conditions.
see.
Yeah,
Okay.
there's like a command called PO split rooms that you can use to actually just slice it with another geometry or something like that to be able to, say this part's below, this part's above. Yeah. So there are a few different workflows for that, but yeah, I mean, yeah, there's so basically, right, there are default assumptions built into this when you create these rooms from these solid geometries. Right. So if I go back, I'm just going to make sure, I'm going to use the what I had by default. I was just moving this around to kind of show you guys at least what those assumptions are. But I'll say select geometries and hit enter here. And so you see, right, so it knew that this was a ground plane because this, it's just this floor surface that's below the Rhino origin. And it also, right, the way that it figured out that this is a roof versus a wall versus a floor, this just has to do with whatever direction the surface is pointing in. And so if you actually had a gabled roof here, it would probably still count the actual parts of the gable as a roof up until a max roof angle. And if you do it, that roof angle is actually something you can change on the command. When you go to select geometries, yeah, you can change the maximum angle at which a given face is considered part of a roof versus part of a wall. So all things to be aware of here that will, kind of streamline your workflows. But all right, the important thing is, right, that we have now room geometries here basically converted from the 3D model. And if you go over to looking at the boundary conditions again, there, while the ground boundary condition is correct, there's actually something about the boundary conditions that I'll tell you right now is not quite correct yet. So I don't know, does anybody know what that is? What we may need to fix about this? Maybe I'll give you guys a little tool that'll show you something, then you can tell me. So there's this little very useful option here called renderer settings under the pollination tab. If you left click on this will give you a little menu that allows you to turn off certain face types and certain boundary conditions. So for example, in this case, I can turn off the roof ceilings, right? And I can say refresh and it will turn off the actual roofs that are in the model. So that I can get kind of a view down into the actual model. And maybe actually looking at this, does anybody see something that we probably need to change in order to make this, at least for energy modeling, what we should be changing about this? Is there, I mean, it's not really that much of a trick question, but right, but these walls, right, are supposed to be interior, right? If this is all part of a single family home, and what does the boundary condition say that they are in this case?
Outdoor.
Yeah, they're outdoors, right? So this would not be an accurate energy model at all right now because we're going to get all this heat exchange with the outdoor air through these surfaces, which is obviously not realistic. We're going to have heating and cooling loads that are through the roof because it's assuming these interior walls are exterior exposed. So the way that we actually can make sure that these rooms are adjacent to each other in the in our pollination model here, we have a single command that will basically take care of all of this for you. And that's command is just called solve adjacency. So maybe I'll turn the roof ceiling back on for a second now, and close this.
Hey, Chris,
But I'm
so
going to use this command. Yeah.
with what you have enabled on the display settings, is there a
Yeah.
legend that would have told, let's say, new users that means
Yeah.
outdoor?
That's this is a really good opportunity to show something. So right now, I mean, we use these kind of colors that if you know what they mean, it's very helpful and quick. But yeah, you may not know like exactly what these colors mean by default. So what you could do is you can use this color by face property option that we have here. And there's actually this ability to color by not just the boundary condition of the face type, but if you're, let's say, to select boundary condition in this case, it'll give you a little legend that corresponds with that. Right, the colors may not be the most beautiful because these are the most, just the default ones, but it will give you a legend that says, okay, this is outdoors, this is ground, and there's no interior or what we call a surface boundary condition in this model right now. So yeah, very good question, right? You can always use this to check if if you want to say the face type also, right? This gives you the wall, roof, ceiling, floor, right? You can always get a legend this way. And if you do want to change the colors, you can actually always double click on this legend, and then there's a whole bunch of things you can customize about the legend. And we have presets like, I don't know, EcoTech colors, or like, I don't know, this is I don't know, multicolored Ladybug. I don't know. You can see, right? We have a bunch of different options here. And you can customize the legends if you want. But we'll actually, there are a lot of, we're going to be getting deep into using this to QA/QC the model in a little bit. So maybe I'll just go back to this, this preview by boundary condition this way for now. But that's a really good question. If you're a new user, you can get a legend easily by using this menu for it, this color by face property. Okay. So any other questions before we go and solve adjacencies to get interior boundary conditions here?
I want to add a comment here quickly that the reason this one doesn't have a legend because we are using a different type of technology for visualizing this. And one of the good things about this is, for example, you can make these colors to be transparent using the same filtering that Chris showed. So the one on the right, the one that
Rendering settings.
filter render setting.
Yeah, under rendering settings. Okay.
Yeah, and then transparency. Yeah, like that, and we have talked that there, like we should really have a legend for this too. It makes sense, but for now, that's an alternative solution to get the legend.
Yeah, this is nice because then we don't even need to turn off the roofs basically for you to be able to see that there's no indoor boundary conditions, right? It's all blue.
Right, and be careful if you have a very large model and you set the transparency to non-zero. Rhino can struggle. I mean, but very large model with this. Totally.
Yeah, I mean, you need hundreds of rooms basically to do that.
We have done a lot of optimization. Yeah, but still, you can break it if your model is large,
Yeah. Good to, glad you pointed that out. All right, so cool. All right, well, now that we can clearly see that this model isn't correct yet, let's go and actually run the solve adjacency command. I'm just going to type PO solve adjacency. All right, this is all built into this one command. And you can see the solve adjacency has a bunch of options. It'll do actually the intersection process for you to make sure you get matching surfaces. As you see all that was one of the golden rules of honeybee geometry and of pollination model geometry. So the command will take care of this automatically for you in the intersection calculation. And then it does a matching, which is basically the assignment of that indoor boundary conditions. You could also set like custom constructions on this, but I think all the defaults are good for our case here. So I'm just going to select all the rooms of the model and hit enter. And the command is smart enough. It should only actually operate on the rooms, even though I selected a bunch of other geometries there. And we should see when it's done, I think, okay, can't quite see it through the transparency, but but these interior surfaces now have a different color that corresponds to a surface boundary condition, right? An indoor boundary condition, right? And I guess I could probably see that under the rendering settings if I turned off the roofs, right? Yeah, you can see where I can turn back the transparency on, right? We're now getting all these interior walls have been set correctly. And the one rule that you do need to make sure you follow with that solve adjacency command is that the surfaces do have to be touching each other. So they have to be physically close enough within the Rhino model tolerance in order for, for the command to solve, do the intersection and solve adjacency. And what we'll see actually at a later point, you can sometimes get very, very tiny gaps. We have commands that help you identify that too, which I'll show you in a little bit. But yeah, but as long as you get the geometries to actually be touching each other, the solve adjacency command will take care of a lot of stuff for you, the intersection and the assignment of these indoor boundary conditions. All right, cool. So I think at least our interior walls are correct right now, right? We've built this multi-zone model correctly. Does anybody have any other questions, at least on solve adjacency, before we move on to actually assigning these apertures to the model, these windows?
Maybe just quick description of the set air boundary option on there.
Oh, sure. Yeah. I mean, yeah, let's do that actually. So let's suppose actually, I know in my mother-in-law's house, these two rooms are kind of adjoining each other. So what you can do is, right, if you do solve adjacency with these two, S-V adjacency with these two ones, right, and you can change set air boundary to yes, and that'll make sure, right, that in the process of solving adjacency between these two, it will, it'll do not just assume an opaque like gypsum wall, it'll actually assume like an air boundary across which you can actually get radiant heat transfer, and it'll be a transparent material in your daylight calculations and stuff like that. Maybe just if you are going to use air boundary after solving adjacents initially, I kind of like to turn the intersection off, because there's no real need to redo the intersection, and this will make sure that none of the IDs of the rooms of the actual faces get changed in the process. So I think if I turn that off and I hit enter, yeah, I mean, you'll see this, the boundary condition is still surface, right? Because it's an interior boundary condition. But if I were to go over to color by face type, yeah, you'll see this is now an air wall, basically an air boundary between these two rooms, as opposed to being a solid wall, basically a solid gypsum wall. Yeah, good question. Good question about that. Any other questions on the solve adjacency stuff?
Sorry, Chris, can you just show me how you selected the rooms again? Because I can't, for some reason, it's not changing in my model.
Yeah, I mean, so well, so you have the 3D layer on, right, and you have the room showing up here, right? So you've created the rooms correctly.
Correct. Yeah.
Okay, and you just need to select them for the solve adjacency command. Is that right?
Yes.
Okay, so if you're doing that, then all that you need to do is once you type solve adjacency, you can actually just draw your cursor over all the whole model in this case, because solve adjacency is one of those commands it'll actually know if it's not a room, it'll just ignore it, right? So you can just basically drag it and select all the rooms and hit enter, and it'll still work without issues. In that case. So yeah, so that's how I selected them. I mean, yeah, again, there are many ways to select things depending on, because we have different levels of detail where we want to select stuff out. So you could also always go, right click on a layer and say select objects, and that selects just the objects on the layer. That's a valid way to do it too. Right, or you could even go, I don't know, if you only want to solve it between the two rooms, like what I just did, right, all that I did was I clicked on just the edge of each room that I wanted to select to make sure that I got those.
That's great. Thanks.
Yeah, no problem. All good questions. And any other questions before we move on?
Chris, just another comment. You can use also PO cell rooms to select all the rooms that you have. That's
also a really good one. Yeah, just showing all the options that we have here, right? Cell rooms works just as well. Yeah, and you could it won't select hidden stuff, if you want to use that as a way to control what you're selecting in a large model. Yeah, I mean that becomes really useful when you have, I mean, yeah, the hundreds of rooms or 1,000 rooms as we've had even in some models. So yeah, but we're starting simple. We'll work our way up there. All right, cool. So I think, yeah, so we have I think our boundary conditions are correct. Yeah, our face types are correct. So, all right. So unless any other questions before we add the apertures? Awesome. All right. So what I'm going to do right now is now that we have, I'm going to keep this, color by face type selected so that we can actually see the apertures once they're added. But in order to do this, right, we're going to use that same button that we used previously. So I'm going to left click on it. But now instead of doing apertures by a window to wall ratio or drawing the apertures, we're going to just select geometries in this case. Right, so if I just go to select geometries, I could certainly, select them one by one and hold down shift and basically select all these cyan geometries that I have in the model here. Or I can go over to the layers menu, like what I just used here, and right click on the Windows layer and say select objects, right? And that's another way that'll select all just the window geometries that I care about. Right, but either way, whether it's through that or by holding down shift and individually clicking on the edges of each of the windows, right? As long as you get all those selected and you hit enter, right, the command, oh, actually, I'm sorry, I did the command incorrectly. I always do this. So you see, right, actually, the way the command is structured, and this is why I have to read the prompts here. I just hit escape to get out of this. So when I go and I say select geometries, you'll see actually it first asks me, I should always read this. It wants you to select the orphan faces or rooms to which you're adding the windows geometries. So this is even before you go then select the actual windows there, right? Just make sure you select the rooms. And maybe we'll just use one other way that we can select them. You can actually select them in the tree menu here. So if you just hold down shift, you can go and select all the rooms like that. Basically, and that'll make sure that they're, all the rooms in your model are selected. You could also do control if you just want to select a few things out of that tree menu. So that's how I'm going to select my rooms in this case. I'll hit enter. Now to select the planar surfaces that represent the windows, I will do what I just did previously, right? I'm going to right click on windows and say select objects, right? And now I think when I hit enter, right, once I have all those windows selected, it'll actually add those windows as geometries to the rooms. And something must have happened to the preview here. Let me see, because it does. Did it actually add the apertures? Let me see. It looks like somehow it didn't add the apertures. All right, maybe let me just do Control Z one more time and just try this again. So maybe it was the way I selected the rooms. Let me just try this one more time. I'm going to left click on select geometries. And maybe, in this case, right, I can go through and select the individual rooms like this, or I can go over to, let's see. I can also just, go over to the layer that has rooms and say right click and say select objects. But I think maybe it's because because they were selected in the tree menu. Let me hit enter now, and let me right click on windows and say select objects. Right, and then hit enter. And I think, now it knew how to add them correctly. So sorry about that. Maybe the selection that I did in the tree menu, maybe, I don't know if this was a bug or something that we should probably try and fix. But I guess when we selected them this way, right, you probably want to make sure you have the geometry selected and not just the room object selected, I guess is the moral of the story. All right, I'm sorry that took 3 tries to get it. Does anybody need to see it again? Would anyone like me to show it again? Maybe I'll just do it for good measure in case, I don't know. So, all right. So what I did, I just clicked on PO add apertures. I said select geometries. I can go over to the rooms layer, right click on it, say select objects to select those room geometries, hit enter. And then I can right click on the windows layer, select objects, and then hit enter. And then those windows are added to the rooms. And you should be able to see through them, basically. They should be transparent. If they've been added correctly.
So it looked like it was kind of partially added, right? Like some Z fighting or something?
I think it converted them to apertures, but I guess it added them as orphaned apertures because of I guess because I didn't actually select the individual room geometries. It was, I mean,
I had recreated it at my end, but it was weird. It was like you said, it was created aperture, but not added to the room. And I guess one way to double check is, what do you recommend? But maybe you could isolate the room, and if it doesn't pull the aperture with it, then you'll kind of notice.
That is certainly one way to check. You can isolate the room by double clicking on it, right? Because you could always see by double clicking double clicking on the room edge. Whoops.
Because
why it's
you turned off the room selection.
Oh, gotcha. Yeah. Oh, that was probably why. That may be why, actually, if I had that off. Yeah, right. If I, yeah, you should be able to see when you double click on a room, right? It should highlight the aperture with it to make sure that it's added. I mean, the other thing is that if it added it as orphaned apertures, right, what you actually see is a whole other menu for orphaned object management that's separate from the room objects. So, right, if they were orphaned apertures, you'd actually see them show up under this menu when you clicked on it. Whereas, yeah, if you go back to the room manager, right, you actually see, if you expand some of these faces, you'll see the apertures are underneath there in the tree menu. They're being assigned to the walls. Yeah. Yeah, so sorry about that. What it is probably we haven't noticed it before because usually we keep the rune selection on, which is a good default, I think. But yeah, if it was off, that's probably why I didn't know to actually add the, yeah, that's why it tried to add it to the faces and not to the actual room objects. Yeah. Okay. All right. Well, hopefully no one experienced that issue on their end. But yeah, if you did, it was probably because of the room selection toggle here. All right, any other questions on how to add apertures, at least using detailed geometry like what we did here? All right, if that's the case, then we'll just there are two other things that, to give you the full tour of all the honeybee objects, right? So you guys have gotten the sense of like rooms, faces, and apertures, but you'll see we have a front door here in the model, like a surface that represents that. So we're just going to add the door into our model so you guys get a sense of those workflows. It's very similar to the workflows for adding apertures. But in this case, right, we're just going to click on the add doors button and, and we'll do select geometries in this case because we already have the geometry created in our scene there. So what you'll do, just like with the rooms, right, it'll ask for the orphan faces or the rooms to which you want to add the door. So in this case, right, if I just click on the edge of this big room space here, right, that's the one I want to add the door to. As long as I have that one selected, I can hit enter. And then I just need to select this one little door object and hit enter, right, because it's asking for the planar surfaces for creating doors, right? And as soon as I've done that, it'll add now the door to my model. You'll see it's going to show up in this shaded like brownish color, right, to show that it's being modeled as a door. All right, and that's all that you have to worry about there. For adding doors, very, very similar to apertures. I think we'll even add like similar workflows for, yeah, we said that for drawing doors that are very similar to apertures if you need to draw them from scratch too. That's doors, very, should be a refresher at this point. But lastly, the last thing we have are these shade geometries, right? We have all these surfaces basically, and I have them all on one layer here, basically the shade layer in the model. So we just need to make sure that this is going to be modeled as actual, like, building shade in when we go to send this off to a radiant simulation or an energy simulation. So in order to do that, we're going to use this very last add button here that we have, last of the 5 that we've made geometry objects, just to say add shade. And if you left click on this, right, you'll see you can actually add shades that are aperture shades, or they're hosted by a room, or they're building shade, or they're completely site context shades. Probably something like this, which is like a roof and a garage and a backdoor overhang, right? This is probably building shade in this case. But you guys remember how I was saying earlier, right, that shades can be assigned at all these different levels of the model, right? So this is basically what it's saying here, is that you can basically set up these shades to be hosted by different objects. So for now, I'm just going to select building shades. And I'm going to, well, I can go through and individually click these shade layers, but I think it's just going to be easiest if I left click on the shade layer here, say select objects, right? And that'll make sure I have all these garage surfaces and the roof surface and the backdoor awning surface, all that's going to be selected. I'm going to hit enter, and then you'll see the color we use for shades, at least when we're doing this color by type, is that it's going to be a purple color to try and differentiate it from the other stuff. But right, so that indicates now it's no longer just raw geometry. This is actually model geometry. This is simulation geometry that'll be in your Energy Plus and your Radiant simulations. Okay. All right, so I think now we basically got the geometry complete for this model in this case. And I think actually maybe we will put a pin in this model right now because there's one more major workflow that I want to walk you guys through before we get to actually like running some simulations with this geometry. Does anybody have any questions on this, on this workflow of creating the model geometry from, your raw Rhino geometry, or on, on the drawing workflows, any of this stuff before we get to the next step where we're going to be actually cleaning up an exported Revit model and turning that into something simulatable? Yeah, and I can see there are a lot of good questions in the comments here. Yeah, or at least in the chat, I can see. Yeah, so thank you, Mustafa and Mingbo, for helping everyone out here. But yeah, there are commands for like setting air boundaries based on the guide. Yeah, there's a lot of great stuff. And actually, maybe I should point you to this, right? If you ever are looking for, you're not sure if there's a command to do something, chances are there probably are a command. So we have this docs.pollination.cloud user manual here. You can always find it if it's off of our main website too. Like if you just go to pollination.cloud and then under resources and user manual. So yeah, but you can see here, there's like, we have a full list of all the commands that you can do in pollination with descriptions about what they do. So you can always look up here if you're unsure of how to do something. And there's generally also a lot of like how-to guides about how to get started, what the best practices are in Rhino. So yeah. So I'd recommend checking this out here if you're wondering how to do something, or if you get stuck at a certain point, because chances are there's a command that does it already. And if not, then ask us on Discourse because we'll add it. I'm sure. Okay. All right. Any other questions maybe before we put a pin in this model, and we'll start with by cleaning up some Revit exported geometry. All right, then if that's the case, I don't know, maybe I'll save this just in case you guys want to reference this. Right, this is our shared Google Drive here, and maybe I'll make an in-class subfolder. Right, so in this case, yeah, single family.3dm. I'll just save this. This will have all of the properties of the energy model if you guys want to check them against your own model, or if you need to reference this in the future. But right for now, I'm going to kind of, put this model away. We'll say that this is basically, we got this to a point of simulatability, right? And I want you guys to now, we're going to work from this second file that we have in the Google Drive here, which is just the Revit sample model.hpjson. And so if you guys aren't familiar with this file extension hpjson, that's because it is our native format of a honeybee model of our pollination models, basically in this case. And the thing that we promise whenever you save things as an HPJSON or open up an HPJSON in our software, all of the attributes that you assign to that model will come through that import and export process. And we can't always guarantee, like, let's say if you import an IDF, that we're going to be able to bring everything from that IDF into our software. But from an HPJSON, you will always get everything coming through. And actually, if now that we have the docs up here, if you guys did want to know about what things do come through, let's see, we have an interoperability page here somewhere in the Rhino plugin. Yeah, here we go. Right, and so I think this page will tell you, or at least the import page will tell you, right, this is all that we import. So from HPJSON, right, we always can import geometry, space, boundary conditions, space types, window constructions, everything. From OSM, we can import most of these things, right? So the Open Studio model format, we can import geometry, boundary conditions, some schedules, loads even, right? But from GBXML, because there are limited representations of schedules in GBXML, we can't import those, but we can import constructions and geometry. And then IDF also has its own things that we can import stuff from. Right, but so the thing to bear in mind is that, right, we try and always be faithful to geometry with importing it, but some of these other properties that you may assign for an energy simulation may not always come through unless you're using the HPJSON. In this case, actually, the HPJSON, this was a Revit export, right? This is the Revit sample file. So I'm just going to drag and drop this onto the canvas of the Rhino model here to open this up. So I'm really just using HPJSON in this case to bring the exported geometry from Revit over into Rhino so that we can like flesh out the model a little bit more. Once you drag and drop this onto the canvas, right, it'll tell you to open, you can open the file or insert it. In this case, we just want to open it and replace what we have here. So I'll hit OK. In addition to that, you could have also gone to File, Open, and navigated that file. But as long as you're opening up this file within the Rhino plugin, that should work. Right, and you can see as soon as you open an HPJSON within the Pollination Rhino plugin, we instantly do a validation process on it. And the reason why we do this is because almost always, if you just like importing something from, you don't know where, there could very much so be issues with the model. And in this case, right, we at least have one issue that we see here. This room entry hall has an invalid subface, an invalid aperture door, right? And it's actually telling us this aperture is not coplanar or bounded by its parent face, right? So we do this, right? We'll give you a report as soon as you import, so that you're always aware if there's something that's going to make your model unsimulatable, you'll be instantly aware of it, even before as you open it. So I'm just going to hit OK, and we'll just say, we're going to have to fix that at a later point. Right, the next thing that'll pop up is that it'll say it's going to try and match the Rhino model units to whatever units of the HPJSON. Because I think Mustafa told you this morning, Revit is natively in feet. This HPJSON is in feet. So we'll just say yes to convert our Rhino model over to feet, so that we can be true to basically the original HPJSON. And as soon as I open it up, right, you'll see, let me just make the perspective window big here, right, that this is the Revit sample model that we were working on this morning. And I can see that my renderer settings are still the way that they are. I can turn back on the roof ceiling here so that we can kind of see everything all together, right? But this, again, this should look familiar. I know we're getting a lot of use out of this this Revit sample model. And you can see, I'll admit, actually, this model was already cleaned up a little bit in the Revit plugin. It's not a pure export of the original model like what Mustafa did this morning. But there's still plenty to clean up in this model. So don't worry, we're going to have no problem walking through a lot of different Rhino commands on this model right here to clean it up. But you might not know it just looking at it right now, right? Because it looks pretty good, actually, that it exported. Right, but at least we know already, right, that there was something invalid about the model because of that initial validation error. So what we can do is, if we want to be able to find and locate that error, that validation error that we got in the model, we have a dedicated command that always lets you check to see if there's something wrong with your model. And it gives you a really nice interface for actually zooming into the different parts of the model that may be affected by the validation error. So that command right now is PO validate model. If you guys just click this command once you've gotten this Revit model open, you'll see, right, it'll ask you if you want to validate just a subsection of the model, right? If you don't want to validate the entire thing. By default, I'm just going to hit enter and that'll validate the entire model. Of course, that can take a long time for a very large model, but in this case, right, this is only 15 rooms or so. This is pretty quick. Right, and the nice thing about this is that it'll give you, it's basically gives you that same validation report, except that now you can get this in a nice organized list. Right, so in this case, I actually get a drop down of this. I can actually select this individual validation error that I've gotten here. And there's this really nice feature of being able to show exactly where in the model this validation error happened. So if you hit the drop down, make sure you have this one selected and then hit show. Right, it'll zoom into the part of the model where this problem is happening. And I can actually see right now, okay, here's my invalid subface, my invalid aperture, right? This is extending past the boundary of the parent face. This is violating one of those 5 golden geometry rules. And so I know there's only this one error in this model, but like we do checks for all 5 of those rules. Basically, if the room is not solid, you get a validation error about it. If you have a non-planar surface, you get a validation error about it. Right, there's a lot. This command will basically do anything that could make it unsimulatable or not follow those rules. Right, will be checked in this command. And you'll be able to zoom into whatever part of the model with this show feature to show you exactly what's wrong. So, all right, so first thing, before I do anything else, let's just fix this aperture that we know is broken in this case. Let's make sure that it's coplanar with the parent face. And we can kind of see what it's supposed to be, right? Probably we have other apertures here that are at least, a little bit on the inside of the parent face. So let me go, I can actually leave this validation window open right now and still do this change. So what I'm going to do, I'm going to double click on this room in order to enter the room edit mode. I could also just turn this room selection on off and do it that way, but I think it's kind of nice if I know this is just the only room that I want to edit. If I double click on the edge of this room, right, it will bring me into a menu where I'm now only editing this room. And that'll allow me now to select this aperture such that I can edit the geometry of this individual aperture and basically make it valid again. So what I'm going to do in this case, I could do this a number of ways. I could do this with the native Rhino move edge command. I'm kind of a fan of the native Rhino scale 1D command. I use that quite a lot. So I'm going to use that right now, scale 1D. And as long as I have this aperture selected right now, this aperture geometry, I select scale 1D. This will allow me to select a starting point, an ending point, and then a new point that I want to scale it to, basically. So in this case, I'm going to select the very top right corner of the window here. I'm going to snap to the endpoint. I'm going to select the very bottom right corner of this window, snapping to that endpoint. And then I basically want to snap it to this height right here of this other adjacent window, right? Snapping to that endpoint. And you can see, right, it's scaling the whole window in this one dimension. So if I go and I just click on that right now, it has scaled this window in just the vertical dimension here, right? Just in that dimension that I selected, such that now it's basically in plane with that parent face. And I've fixed now this geometry problem that I have with the model. So in this case, right, once I've scaled 1D like this, which maybe I'll just show this again because I don't know, some people, this may be the first time that you're using Rhino, right? Just make sure you have this aperture selected, type scale 1D, hit enter, right, and just select the upper right corner, the lower right corner, and then the neighboring adjacent endpoint, right? And that'll make sure that you've scaled it into that correct point there. Right, and then you can double click up top here to exit this room editing menu. And now, right, without even closing the validation report, I can now revalidate the model. So if I just left click on this, right, it'll ask me if I want to validate selected again. I'm just going to hit enter to say I want to validate the whole model. And hopefully this time it'll tell me, oops, I have to hit enter while on the scene. Right, it'll tell me, congratulations, the model is valid. This is now at least simulatable in an energy engine. It won't give me a fatal error and crash, basically. So, all right, so let me hit OK here. So, all right, so any questions at least on the how that that validate command works, or at least, or if anyone needs to see me fix the model again at any point, anything related to that?
Chris, I wanted to mention two things here.
Yeah.
One is when you run the validate command, when Chris ran the validate command and there was a validation error, there is a button there for more info.
Oh, yeah.
Know about what this validation means the first time that you get the error, you can click on that.
So yeah, let me show this again. I just undid the fix that I did here. Right, so if you click on more info, yeah, okay. Right, so this, yeah, so this links you. We have actually documentation on every type of error that you can get. And in this case, what is this? Was an invalid subface geometry, right? So if you ever are, lost about how to actually fix this type of error, I mean, in this case, maybe it's hopefully pretty obvious that the window is out of plane or out of, extending past the parent face. But right, if you ever need, suggestions on how to fix this, right, this will tell you exactly, give you some suggestions about it. And you can see, right, this also gives you a full list of all the things we check for, right? We check for duplicate identifiers, right, which would, create collisions of IDs that would make things non-simulatable. We check for non-planar geometry, like I said, right, these 5 golden geometry rules, self-intersecting geometry, invalid subfaces, overlapping subfaces, non-solid room geometry, right? And we check even a bunch of properties related to energy too. We check adjacencies. We do a lot of stuff under the hood of this validation command. Basically anything that would make it, so the pack that we make with everybody is that if you are able to create a model that passes this validation command and it is not simulatable in Energy Plus or Radiance, that is a bug on our end and we will fix it. Either we need to make the validation command better, or or we need to that's probably usually we need to make the validation command better, or we need to add a new rule in or something. But that's a pack we make. So if it's passing the validation command, it will be simulatable. We won't guarantee the simulation is an accurate representation of your building because that depends on lots of other things. But it will be simulatable.
Right.
Okay.
So the other thing that I don't know if it will work for this particular case, we have a new command that called PO offset child objects, which basically I don't think we can say if it will work in this case too. It should, right? It should automatically fix the aperture when they're outside. So if you command, probably.
Let me try this. So what it's called PO
Offset.
Offset. Yeah.
Offset child objects. Okay, so we have to select the rooms, and notice, like, I've never used this command before, but notice I could follow it just by reading the prompts in the command. So let me see. Well, hopefully I'll be able to follow it. I might eat my words. So that, all right, I need to select the rooms that contain child objects. So I hit enter, and it asks for the offset distance. Okay. Okay, that
This-
seems good. That's
Yeah,
in
this is like a
meters or feet.
tolerance. This is a very, like how much you want this to be offset.
Yeah, okay,
like
so
a
0.005 feet, that sounds good. All right.
That's
Or actually,
probably
maybe
too
I need to
small.
change this to be within, yeah, maybe I'll make it a little coarser just to be safe. Okay.
Yeah, hopefully it's too small because that distance probably
Oh,
larger than 1 feet probably.
I see. So this is the distance at
foot.
which, okay.
Mhm.
All right. Well, I mean, yeah, I guess I could see how that's really useful. I mean, I'm sure we had, like, there are a lot of cases where, especially I know coming from other interfaces, right, where it'll be, right at the very edge or
Yeah.
something like that. You can, yeah, it sounds like it'd be useful. in
Right,
this case.
yeah, like you
So
have
if it
made
was,
more wrong than what we usually get.
yeah, I made it too wrong, I guess.
Yeah, just like this is
Right,
even
so I
very,
could select the room in this case, maybe, and then select the offset distance of 0.01
or
feet.
something.
And
Would
then,
be-
yeah, and I can see, okay,
maybe
yeah, it
like
added a little bit in there, right? So it's now offset. Okay, that's cool. Yeah, that's useful. Let me see if it's valid now. Yeah, model is valid. Okay. So cool. That's another really useful way to fix it. I meant,
And-
especially the doors and other interfaces. I know they come. Oh,
well, this
actually,
is- that one is okay. I mean, like that's because very close to the edge of render issue. It's not a validation issue. But I think
Yeah,
this is a good
okay.
opportunity for us to mention. So if there is something that you do over and over for fixing models, and you think it has a potential to be a command, that's something that we're really interested to hear. And we are adding these new commands, for cases like this. So it just makes everyone life easier. If there is something that you have to fix every single time, right? Then you want to have a command for it, just automate that process.
Yeah. Yeah, I guess this is all just a rendering issue. I mean, I might just go back to see if I can get this to work. I guess I still have the rendering issue in this case. Maybe if I, all right, well, we know it's valid, right? If it's passing the command, right, then it's satisfying the, the pack that we have with everybody, right? That the model is valid at this point. So, all right, so that's the very first thing, like, 101 is make sure that you know this validation command, because it's the, it's the glue that holds everything together and make sure that things are simulatable and that you're always aware of any issues in the model. But of course, right, as I said, okay, so the model is simulatable, but it's not necessarily an accurate model at this point. And so what I'm going to do right now, these face types and the aperture types, they seem correct. They're coming over from Revit. I trust that these doors actually maybe are real doors in the real model. But let me check the boundary conditions for this case. So I'm going to go and color by boundary conditions. And one of the first things I'll notice is that, well, this thing that I thought was kind of probably a slab on grade has an outdoor boundary condition. This is already something that maybe I want to fix in this case. And maybe I will also I'll use these renderer settings and turn off the roof ceilings so that I can get a look inside the model. And lo and behold, yeah, there's definitely some things I need to fix in this case too, right? Because all these interior walls are, are outdoor boundary conditions at this point. So, all right, so very clearly, right, what do we use to make sure that we assign correct indoor boundary conditions in the previous model? What was the name of the command? Do you remember it? It also is the same name as a grasshopper component, PO solve adjacency. Yes. Okay. All right. So that's what we're going to use right now, right? To basically set everything to be an indoor boundary condition, or basically automatically do this intersection and figure out stuff for us. So I'll hit solve adjacency. And I will go, I'm going to select all the rooms in the model, and you'll see, right, it may not select the apertures, but that's okay. As long as you get the room, actually, they're all the room objects. I just dragged across all the rooms there, right? Then everything's going to be all right. So just make sure you type PO solve adjacency. Make sure do intersect is yes, do match is yes, and set error boundaries no. I think, yeah, those are all the default settings. So knowing that, I can just hit enter, and then we should see that hopefully all these indoor boundary conditions will be set correctly. And I already have the color by boundary condition set up, so we can see right now we're getting some green colors coming through with our indoor boundary conditions. But there's a number of things actually that are still wrong with these boundary conditions. I mean, it took care of 90% of them, I'd say, but there are at least two pretty big errors with our model right now in the boundary conditions. Can anyone spot them? Also, if anyone needs to see it again, just let me know.
It looks like one of the walls is still blue.
Yes, right. Yeah, one of these walls that looks like it was supposed to be interior is blue, still outdoors. And if we zoom into this, we can actually see, right, that this is one of those cases I mentioned earlier, right? We have two surfaces that are very close to each other, but they're, not perfectly touching. Right, so that's why the solve adjacency in this case failed, right? It thought that there was actually a gap in between these two, right? This is just a command, right? It needs to have these things touching each other. So we can see, all right, so that's definitely one thing that we're going to need to fix with this. But you can see actually it re-intersected everything. Yeah, to get this little sliver in here. If you guys did want to know to be able to find something like this earlier, by the way, there is a command that we have called PO check geometry adjacency. And if I use this right now, what this command does is it will tell you basically you have to select the rooms that you want to check. And I can select all the rooms in this case. Right, and it will ask you for a threshold of how close things should be in order for it to be, this is too adjacent but not perfectly touching. So if I increase this a little bit, it'll actually start to show me places in my model where I have all these conditions of little like things that are very close but not touching. And so you can see, for example, I've got 2 points here. Actually, yeah, here's something that would have slipped under my radar unnoticed, right? I have this little sliver face here. Right, that is, not doing anything except making my simulation take longer to run, right? This doesn't serve any useful purpose. Right, and I guess I'm not getting it for this case because it's already been intersected. The geometry's already been intersected here, or maybe I need to bump up the threshold more. I don't know. But in any case, right, like this little check geometry adjacency command can show you what's going on here. So actually, all right, so we already have found two things that we need to fix, right? So there's this, these faces that are not perfectly touching each other. There's the sliver face in this case. Is there anything else that's wrong with the boundary conditions that anyone notices? X out of that. There's something that's an outdoor boundary condition that should not be. Yes, I saw someone put in the chat. Yes, I guess, yeah, you might be on mute. The slab, right? Or so, well, I guess, yeah, right. So maybe you might be referring to either to this floor slab that should be in contact with the ground, but also the floors of all these rooms on the second story are exposed to the outdoors here. And right, the reason is because Revit exported this model with this gap between the two stories. So, which, you saw Mustafa fix that in the Revit plugin workshop if you attended that. But right, in this case, right, if you want to get the solve adjacency command to recognize this, what we'll have to do is somehow get these two geometries to be touching each other again. If we want to have the solve adjacency command correctly set this floor surface to be an indoor surface boundary condition and not be in contact with the outdoor air. So, all right, let's go down the list here and start to fix up some of these things. So maybe first things first, let me try and fix this little sliver face. And at the same time, I'm going to use a single command that's going to get rid of this sliver face, and it's going to reset all the boundary conditions so that I can, be in a good place to resolve adjacency after I fix all this geometry up here. So that one command that does all this stuff together is called PO rebuild rooms. This is a super useful command, especially when dealing with Revit geometry, because right, you always can get these little slivers, these little jogs and everything. And this PO rebuild rooms, if I go and hit enter, you see it'll ask for rooms to rebuild, but you'll see it has all these options of merging coplanar faces together. Very useful for cleaning up the model, right? That'll get rid of this little sliver face here that's coplanar with the one right next to it. Basically get rid of all those cases where I have an extra geometry that's doing nothing except, making my simulation take a long time. It'll rebuild the faces, right? It cleans up the face geometry. It resets the boundary condition using those default rules that I mentioned earlier. All right, so doing all this together on these rooms, it's actually gonna get me a good, you know, at a pretty good place already. So I'm gonna select all these room geometries right now. Right, as long as you make sure you got the rooms, you don't have to get all the windows and everything. Just drag over the rooms and hit enter. And you'll see it's gonna, you know, basically go through the whole model. That little sliver face that we had previously, right? You should see it's gone away because that was coplanar. You can see we I don't know if you remember, but we actually had coplanar faces in this back gabled surface here, right? That also went away. Those got merged together to make something nicer and cleaner. What else? The boundary conditions are reset. So it got rid of the surface boundary conditions on the indoors. That's all right, because we're going to resolve adjacency. And also, right, because these surfaces were below the Rhino origin here, it actually automatically set a lot of these floor slabs to be a ground boundary condition. So it actually did a lot of the work for me already. Although I can see, right, this is one geometry that we're probably going to have to change the boundary condition of. But let's come back to that in a little bit. For now, right, so all right, so we solved that little sliver geometry. Let's go ahead and try and solve this little geometry that we have here, right? This one that was perfectly close but not completely touching. And you can actually see the reason why this is the way that it is that this floor, basically this room was extruded in a manner that wasn't perfectly vertical. Super common problem that you find in Rhino models, maybe not so much in Revit, but definitely in Rhino, like people don't realize they're not extruding perfectly vertically. So in order to fix this problem, I'm gonna use the native Rhino move edge command in order to do this. So let me see, I'm going to turn I'll turn the roof preview back on just so I can make sure that everything is, I can see everything all together here. But right, so all I'm going to do is now that I can see this gap here, I'm just going to type PO move. Oh, sorry, this is not a pollination command. This is the native Rhino command. It's just called move edge. So I don't need to have the PO in front of it. So I just click move edge. Right, and this will ask me for an edge that I want to move. In this case, right, we'll move this little one that we know is off plane here, right? It's causing this little gap. And then if I hit enter, right, once I'm done selecting that, and I can just snap to the endpoint here, snap to this other endpoint to kind of close the gap, right? It's moving the whole edge in this direction, right? And now we can see that face is now perfectly flush with the one that was right next to it. So that will close that little gap there. And of course, right, we also had on this side, because the whole room was extruded incorrectly, we can do the move edge command again. Let me type move edge. Move edge. I can select this little edge here, hit enter, and then just snap between the endpoints to make sure that's all good here. Okay. All right, so that'll solve that issue. Next time we solve adjacency, that'll be perfectly touching. I won't get this little extra sliver out on the edge here, so that'll be nice and clean. But we still have to make sure that these geometries down here are touching the floors of the room above it, so that we can actually get the solve adjacency command to work in this case. So I'm just going to do at least one more edit before I solve adjacencies. I'm going to make sure I have all these ground rooms selected here. And you can do this either by selecting them like I did by dragging and dropping, dragging over just these rooms right here and trying to get most of them. You could also, I think there are only 5 of them. If you want to just look in your tree menu and select the bath, kitchen, laundry, linen, and oops, not linen. Yeah, I don't know. I can hold down shift in the Rhino scene. Kitchen, hall, laundry, 104. I think there are just 5 in total. As long as you make sure you have the same one selected that I do in the mechanical room. There we go. All right, what I'm going to do, I'm going to use the command that I like to use, that scale 1D. I'm just going to scale all these rooms in one dimension so that it's touching the rooms above it. Right, so the way I'll do this with this corner here, I'll just type scale 1D, hit enter. I'll select this lower right corner of this little room here. I will select the upper right corner, and then I want to make sure that I go all the way up to the room above it, right? I'm just going to snap to the endpoint here and click on that, and that'll scale the entire set of rooms here to be in contact with the floor surface of the room above it. I mean, there are many ways to solve this type of problem, right? Like Mustafa showed you a native way in Revit of like pulling up all the room geometries, but I think this is good enough for our purposes in Rhino right here. Right, this will at least make sure now that they're perfectly touching, we'll get the solve adjacency command to work. Any question at least, or does anyone need to see the scale 1D again, or any question on all this cleanup operations that I've been doing? Okay. All right, there's actually one more thing that I want to do before I go and solve adjacency, which is just bugging me a little bit. You know, I probably don't need to do this, but it's still bugging me, right? The fact that we actually have these two room geometries that are just off from each other a little bit, right? It'd be really nice if they were just aligned and perfectly flush with each other. That seems like that would be like, one, it would just be cleaner, right? As you know, less geometry, and two, it would be, let's see, it would be, you know, probably a better representation of the actual building. So, all right, so for this, I'm going to use a nice useful command that we have called PO align. So for this, the align command works by actually taking axes that you've drawn within the scene and snapping the geometry to them. Mustafa hinted that we're trying to get a lot of these types of features also within the Revit plugin. And we do have them for a lot of the Dragonfly workflows, but we have them almost pretty much fully implemented in the Rhino plugin. So what I'm going to do for this case, I'm actually going to draw a set of lines for, you know, basically what I want to align all the rooms to. So I'll do this very simply by just drawing a line in Rhino with the native Rhino line command. I'm just typing line in the command bar there and hitting enter. And then I'm just going to draw a line, let's say from this corner of the room all the way to this side of the building. And you know what I can do? If you guys hold down shift and then tab, that'll make sure you snap to the world Rhino axis, which I think is kind of useful a lot of the times because, right, because it'll make sure that everything, yeah, everything basically gets aligned to that Rhino world origin instead of something else that's off the Rhino world plane. Right, so I just held down shift and then tab, and that allows me to stick to this axis. And I can now go all the way to the very end of the model here, right? And so this gives me a line that I'm basically going to line everything to along this edge. I want probably something similar on this axis here, right? Because these two are also just off by a little bit. So I'll draw another Rhino line, and I'm going to click from here. Maybe I'll do shift and then tab again. So I'm snapping to this world y-axis basically in the Rhino scene, and I'll make it go to the end there, right? And so once I have these two curves drawn, I have basically what I need in order to align the model to these curves. So I don't know, does anybody need to see the line drawing again, or just have any questions at least on that? Okay. All right, so I'm gonna run this command right now. So let me type PO align. And specifically, I guess we want to use the align to grid, right, Mingbo? That's the right one. So if we select this, right, this will actually use a grid generated from our line. So we need to select the geometries that we want to align first. So that's just our rooms. And again, I can just do a very broad selection of every, you know, all the rooms. As long as you're touching each one of the rooms in your selection there, that should be good. And I'll hit enter. And then, right, we have a bunch of options on this command. So we have a threshold, which is the distance, you know, away from the line, at which case it'll snap to it. In this case, actually, yeah, I think we will need more than 0.01 feet. Yeah, I think I measured this earlier and it was something like 0.33 feet. So let me change this threshold right now. I could have used the native Rhino dist command to figure that out if I didn't know that. But let me change this right now because I'm in the middle of the command and I want to show you this. I'll change it to 0.35. Seems like, yeah, that as long as it's more than that, that'll work. And I'll hit enter. The next thing I want to do, I want to snap. Basically, you can either snap to X or Y or Z, or X and Y at the same time. In this case, this would be both an XY case because we have, you know, one X axis that we drew, another Y axis. So I'm going to select this snap XY, and this will basically ask me for lines that represent the XY axes of the plane. So let me go ahead and make sure that I'll just go and select the curve that's here, basically, that I drew along this side of the model. And then I can hold down shift, or I may not even need to hold down shift, and just select the other line. And right, as long as you get those two curves selected, right, those two lines that we drew in the scene, that's the most important thing. And once you have those curves selected, you can just say enter, right? And basically at that point, right, the command will give you a preview of what the grid looks like for these cases, right? The grid that it's going to be snapping to. And this looks correct to me, right? We see two grids for our two lines that we drew there. If I now just hit enter, fingers crossed, hopefully it all just snaps into that one case, and I got the distance right there.
You have to hit enter again.
Oh, I have to hit enter one more time, I guess, now that yeah, in case I want to change the threshold again. But right, in this case, now when I hit enter, it should run. And 83 geometries were checked, and yeah, look at that. That's all nice and aligned together here, right? this now everything's basically, yeah, with using these two curves, it aligned all the rooms together. And yeah, this looks like it's in really good shape now, basically much cleaner than what I started with all those coplanar faces merged and with the everything aligned to that grid right now. All right. Does anybody have any questions?
There is a small validation error that you introduced to the model that you want.
Yes. Very good. Yeah. Yeah. I mean, that's always good. Before you run anything, you'd always do the PO validate command. But right, if I do the PO validate model right now, it'll tell me that the align command did something. Well, we just validate the whole model here in this case, right? There are now two errors that we're getting here, right? And if we click on this little drop down and then go to show, it'll zoom us into the fact that, yeah, that this aperture, right, when we aligned it, the window now got cut short a little bit by the by the alignment operation. So we're going to just have to do one little tweak to these windows to make sure that they are completely inside the parent face. And in fact, maybe this is a good opportunity to use that. What did you call it? It's offset. Yeah, offset aperture. All right, so let me do that right now. So PO offset child objects. Okay, let me do that. I'm going to select this room, right? The room that contains the child objects. I'm going to hit enter, and the offset distance, maybe we'll make it to be just a little more. Maybe we can do 0.1 feet. That's actually, yeah. I mean, then we'll be able to see it clearly. And if I hit enter, right? Yeah, we should now see, yes, those child objects are now offset nicely from the edge there. Okay, and if we then go and revalidate the model. Now we don't want to validate selected. We just want to validate the whole thing. Hopefully now it tells us that the, whoops, I have to enter one more time. Right, congratulations, the model is valid. So all right.
Just adding one comment here. So this is again a new command. So right now it offset the whole thing. So you see like the windows are also shorter a little bit. So this is not ideal. Hopefully in the near future, the command only scale 1D from the site that has issues. I mean, in most of the model, if you do a very small number, I know Chris put a larger number to be able to see it. It doesn't make a major difference, but just something to be aware of. And this is something that will be improved in the next iteration. Just
I mean, and also there are always multiple ways to solve it, right? I could also, I mean, you can tell I'm a huge fail of scale 1D. Right, I could just scale this and then, make sure it's just not touching the very edge there, right? And that's
I think we are following the Rhino logic for the Rhino plugin a lot, that there are several ways of doing the same thing, depending on the case, what you want to do. And that makes the Rhino plugin really user-friendly, in my opinion. That if you don't like something, or if there's a limitation with one command, there's another command usually that you can always use to address the issue.
Yeah. So all right, so awesome. So the model is valid in this case, right? Everything's aligned. This is a whole lot cleaner than what we started with. And again, these were all like little things, right? That you might not have noticed with just looking at the model to start off with. But I think now, oh, interesting, Al. So I noticed that, I guess in the process of doing this, maybe we lost the ground boundary conditions. So if I do want to reset those ground boundary conditions, I can just do PO rebuild rooms again, and just select everything. And this will just help me reset those ground boundary conditions, so that, because I kind of like what was happening there, at least the fact that, that all these got selected to the ground. Yeah, maybe we somehow lost those probably when we aligned to the grid, it must have reset them or something like that. But this looks good now. All right, so everything's aligned. Now we just need to resolve adjacency, right? Because we still, if I turn the preview off on the roofs, right, you can see, right, we still have these outdoor boundary conditions on the inside of the building. So, all right, so let's go and do that now. We'll do PO solve adjacency. And we'll just go and select all the rooms. And hopefully now that everything's been aligned with the other stuff, hopefully this will give us pretty much exactly what we need. Instead of having, one face being off or something else, right? And we can see, now that this face that was off before, that's got a correct boundary condition assigned to it, right? All these interior floors and ceilings are being set correctly, right? These are green, indicating an indoor boundary condition, right? And even, and these faces turned out well over here, right? Everything seems to be mostly good. There's only one last boundary condition we need to fix, I think, right? And we can see that in the menu here. So the way we can do this, there are a few different ways if you want to select an individual face. Like I think we already, this is going to be a review at this point. But if we want to, let's see, if we can certainly turn off room selection, right? And that'll allow us to select just the, or if we hold down Control and Shift, we can use that to select an individual room surface. That's one way of doing it. I kind of like to leave the room selection on because it tends to, yeah, it's good. Like, especially when you're just learning, it's good. Like bumpers, basically, to use an analogy with bowling, right? To kind of keep you from editing things you don't mean to. So what you can do in this case, I can double click the room, right? In this case, this allows me to, I can then do Control Shift and then make sure I select just this one room surface. Right, and then when I'm in this menu here, what I can do, I can either type the PO edit face properties, and that'll bring up a menu that allows me to then change the boundary condition, basically change any of the properties that are assigned to this this face here. I mean, alternatively, right, you could select it. I mean, you see this is living 106. I can try and find the room face within this, within the tree menu here. This is another valid way to edit it. And I can right click on the face and say edit properties. That'll bring up the same menu. Again, there are a few different ways to select these things to drill down, depending on whether you're more comfortable with the tree menu or selecting things in the Rhino scene. But importantly, right, if you just get that face selected, you bring up this edit face properties menu, right? We can now change this outdoor boundary condition to be ground. And that will, once I hit OK, right, you'll see now that's got the correct boundary condition. I can double click and get out of this this menu. And right now, I think we finally have a model where all the boundary conditions are correct. Everything is clean, right? All this geometry is great. And I think we can at least simulate this and say that it's like, at least the geometry and boundary conditions are an accurate representation of a real building like this. All right, I know we've been kind of plowing through this for 2 hours. There are still like a lot of things I want to show you with actually running this model through this and through validating the other properties that relate to energy simulation. Maybe just before, I'll give you guys like a quick break. Does anybody have any questions before we go on a break here? Just for like 7 minutes, maybe?
I have a quick question. So maybe I just didn't understand the align command very well, but does that move all the windows and other parts of the room? Or is it changing the size of it, or is it just shifting? I guess
it's basically, it's just shifting within the X and Y plane, basically, as you saw there, right? So it's, yeah, so all the apertures and all the subfaces come along with the actual wall that's being shifted there. Which is useful, right? Because otherwise, I mean, and you can see actually sometimes it creates invalid apertures, like what happened down here, where we had to rescale that or stuff like that. But yeah, but the apertures are at least being, yeah, the plane of the face changes, they're going to come with that.
Got it. Also, all the interior walls also move with it.
Yeah, I mean, actually, yeah, we probably could have run this command.
So just to be sure, like any face that is within the threshold from that guide will move.
Yeah.
Right, and anything that's connected to them like will be stretched. But for example, that wall there out there, if there is no reason for it to move, that will stay as they are. But this only affects the faces close to the guide. I'll share a YouTube video that I recorded on this command.
Okay, sounds good.
Yeah, I mean, and it's like, I'm sure if you've seen like Revit rooms in practice too, like, yeah, there are lots of little jogs around the columns and, and zigzags happening in the room geometries. This align command can help you like smooth all that out, basically.
Yeah, looks really good. Okay.
Yeah, all right, awesome. Any other questions before break? Okay. All right, maybe we'll give everyone like a full 10 minutes. I know this is in the afternoon. Maybe we're starting to get tired here. So, all right, should we say 4:15 Eastern Daylight Time? We'll all meet back, and then we'll go through some of the final QA/QC commands and try just, yeah, we'll just basically open up some Grasshopper files to show you different simulations you could run. All right, awesome. I'll see everyone in 10 minutes then.
9 minutes now.
9 minutes, okay.
Jace, do you have a question?
No, I was saying 9 minutes sounds good.
Okay, good. Yeah.
Okay.
Yeah, and you can feel free to ask questions on the break too. I think, yeah, I'll be here. All right, well, we got to 4:15. here, so maybe there's still a lot that I'll see if I can pack into the last few minutes here. A lot of this, though, I mean, yeah, at this point we're kind of done with a lot of the geometry cleanup. So most of the stuff I'm going to show you at this point is just like, you know, how to get your model to the, you know, over to the finish line to actually get simulation results out of it. But what we produced already at this point, right, this would be enough to like export a gem file, a GBXML or something, or, you know, send that over to someone using DesignBuilder or IES-VE, or even eQuest, right? We have an eQuest exporter, but right, that this, yeah, this clean geometry, right? A lot of people will use the plugin just as this cleanup process and then get the model to the point where they will assign all the actual energy attributes in another software. But for us, let's actually try and use Energy Plus Open Studio, what we've natively built the connection to within Pollination here. And so to kind of kick off looking at this right now, well, I guess I'll turn back on the roof ceilings here so that I can actually see this geometry as I go and check the attributes of it. But you guys will notice if we had gone back to that color face property menu that I showed you earlier, right? The one that we used to check the face types, right? You can see that, wow, this model has a lot of different types too. We have like skylights and things that we didn't have in our single family home. All right, but you can also use the same exact menu of coloring face properties to check things like the energy construction. And so if I were to do this right now, if I were to select energy construction out of this menu of the color by face property, right, you can see that we have a lot of different constructions in this model. I guess probably because we have a lot of different face types. Right, but all of these constructions are generic. So basically, that's our way of trying to tell you that like these default constructions that we built into Honeybee and Pollination, right? These are not meant to be indicative of any particular building code, any particular climate, right? So if you're going to try and make an energy model that is at least a decent representation of what you would build in a certain place, right, you should be at least trying to change these constructions to something that is at least, you know, representative of a climate. Right, because if we can check, for example, like if you can go down this list, you can see we can look at the R value, for example, of some of these constructions, right? And we can see things like I guess what has the highest R value out of everything in the model is probably, yeah, it's probably, which of the faces, actually, I'll ask everybody, which one has the highest R value based on this little legend that we have here? I know the colors are close to each other. Maybe let me change the colors to something a little different. Yeah, which one has the highest R value? Could you say at this point?
Trees.
The trees. Well, the trees have a none value. Yeah, I realize. Yeah, maybe, you know, maybe there's a good preset actually maybe that we have for this. I think would be energy balance with storage. If I use this one, right, this will make the trees brown. So they're kind of something different. But then these, yeah. I don't know, you kind of want red to be higher. Anyway, right, so we can use different ones. I mean, really what it should be, right, the one that has the highest value that's a number is the, it should be the roof, right? That has the deepest shade of red if you don't go all the way to the whatchamacallit, to the trees, right, to the shade object that don't have any R value assigned to them. Right, and if we see, I mean, some of you may know this intuitively if you've done energy models in the past. If you want to get these values in IP, let me see, there is an option to under settings here in the pollination menu where you can change the units. And in this case, I can use a preset of IP units for everything because I imagine a lot of us are in the US and they may, you know, you might have gotten used to R values and IP like I have. So if I hit OK, right, this will change the R value. Oh, nice. This looks really nice. That changes the units of this, right? You can see that the R value of the roof is 13 or almost R14. Right, and then I don't know if you guys are that familiar with the building code. Let's say like if this was in New York, using the latest version of the energy code, probably you may know like that an R value of 13 is too low for a roof, right? This should actually be something different. This is a generic, you know, typical construction, not really meant to be for a cool climate like New York. So let's say if we want to set all the constructions of this model to be for the latest building code in New York. Right, if we wanted to do that right now, what we can use is basically an object that we can assign to these rooms of the model called a construction set. Now, construction set, this is kind of what like a construction set looks like in diagrammatic theoretical sense, right? So it's composed not just of actually of just constructions that have the material layers and the R values assigned to those, but it also has logic for how those constructions get deployed across the room or across the model. So for example, right, you have a wall subset within the construction set that tells you all exterior walls should get this construction with this R value, all ground contact walls should get this construction, all interior walls should get that construction. Same thing for floors or roofs or apertures, right? So it's got this kind of nice logic about it. And so what's particularly nice about this is that you can make construction sets that align with either your office's basis of design, or if for our case here, they can align with the actual building energy code that of climate zone, the New York climate zone that we want to apply for this. So in order to change, basically, I want to apply a construction set to all these rooms of this model in this case. So I'm going to go and select all the rooms in this tree menu here. And I'll do that just by selecting the first room, holding down Shift, and then selecting the last room. All right, and that'll get all those rooms selected, so that I can now right-click on the rooms and say Edit Properties. And this will bring up a menu that allows me to now edit the energy properties of this of these rooms. And one of them is this construction set, right? This construction set that we want to assign here. Right, and you see the default is by this global construction set, right? That's what determined all these generic constructions that I showed you earlier that aren't really representative of the New York climate. Right, but if I uncheck this box that says by global construction set and then click the little none button here, it'll bring up a list of all these construction sets that we ship with Ladybug tools and with the Pollination Rhino plugin. Right, and if I can see here, right, there are some like 200 or so construction sets, I think at least, and you can see that they're organized by different versions of the building energy code. So these actually correspond to versions of ASHRAE 90.1, which also tends to influence the International Energy Conservation Code, which gets published every 2 years after our release of ASHRAE 90.1. So chances are these are pretty good like representations of what construction someone would build if they're building to a certain year of the code and in a certain climate. So to take the most recent energy code, which is ASHRAE 90.1 2019, right, we can see we have a bunch of construction sets for that. So I'll just type in the search bar here 2019 to bring all those up. And then I'll type a double colon because I now want to kind of pick a specific climate zone number, basically how warm or cold the climate is of this file, of this building that we're making here. And maybe we'll say, right, this is the climate of New York because that's where the AECtech hackathon is happening. Does anybody know off the top of their head what climate zone number New York City is?
4A.
3, did you say?
4A.
4A, absolutely correct. Yes. Yeah, awesome. So yeah, so you can see, right, we have climate zone 4 here, and we can narrow down all the ones that are for climate zone 4 by just typing this into the menu here, right? So we got 4 construction sets that come with this for the latest version of the building energy code. Right, for a residential building, it could be wood framed like this, but you know, maybe we'll say that we'll model this as kind of an office or something like that, because it's probably, you know, I'm sure it's probably more typical of a lot of the buildings that everyone on this in this workshop is working on. And a lot of the times, right, steel frame, that tends to be, I know that's the default that we find in a lot of commercial buildings in the US. I mean, maybe I know in like in other countries, like mass buildings are very common for residential buildings, whereas wood framed is very common in the Northeast here for residential buildings. But steel framed, I think, is a good selection for most commercial buildings. So I'm going to choose that. So if we go and hit OK, once we've got that selected, climate zone 4, right, you'll see it's going to change. This room properties menu is going to change to actually have that 2019 climate zone 4 steel frame assigned here. It's no longer by the global construction set. And now if I hit OK, you'll see, right, this menu of R values is going to update. And instead of having an R14 for the roof, yeah, look at this. Yeah, it makes you appreciate how good the latest building energy code is, because yeah, the R value of the roofs now are at 31 or almost 32 in IP value, right? So this, you can see already like how far off our assumptions might have been if we had just blindly accepted those default constructions right there. And if we actually go and check, we can look at the names of the constructions, right? You know, if I go back to coloring these faces by their properties, right, we can see now the actual, instead of being generic window construction, right, these are constructions with specific U values and solar heat gain coefficients, right? And for a cool climate like New York, it's important to have a lower U value, maybe a little less important to have a lower solar heat gain coefficient. Whereas if we were in like a climate zone 1, like Miami, Florida, right, it'd be much more important to have a lower solar heat gain coefficient, and the U value or insolation level doesn't tend to be as important, right? So that's why, right, if you just pick one of these construction sets that aligns with the climate that your building is in, this will get you at least to usually to a reasonable assumption or a reasonable starting point, at least about what the actual constructions will be on a real building built in this climate. Yeah, and I guess you can see some of these constructions are still generic, but they're all pretty much interior ones, right? And I think, right, if you wanted to check, we have some other properties on these things you can check here. You can check the U factor, which is important for windows, and it looks like a lot of these windows are around like 0.36 U factor in IP in this case, right? Except for the skylights. The skylights, I guess, have a slightly higher U factor. But you can check all this to make sure that, right, you can very quickly QA/QC what the assumptions are. You can see what the solar heat gain coefficient is, right? This is all being dictated by the construction set that comes from the code in this case. Interesting. Wow, the door actually has quite a high solar heat gain coefficient. This must be a glass door, I bet. Maybe if I were to check the face type, that would show me that it was a glass door. But I have, yeah, door exterior glass. That's it. Yeah, that's why. Interesting. Yeah. So, right. So again, we tried to build in all these QA/QC tools so you can very quickly get a sense of what's going on in your model. Make sure that it makes sense to you, that it aligns with what you're expecting you would build. Right. And so this way, right, you're not accidentally assigning a bunch of wrong R values and ending up with energy use that's totally off from what it should be. All right. Any questions on constructions or construction sets? At least how I applied those.
Yeah, just where do they live file wise? Like,
yeah, good question. Actually, and I think this also came up this morning. So the ones that we ship natively with Ladybug tools, we'll actually keep these updated with, as new versions of the energy code get released. And so we ship those actually with the installer and put them in program files. And so you'd see, right, if I go into program files, Ladybug tools, resources, standards, this is actually, so we have some Honeybee standards, which are those generic construction sets, right, the global construction sets. And then we have the energy standards here. And here you'd find there's JSON files that contain all the opaque materials. There's construction sets that have those construction sets that I just applied there. If you want to create your own kind of library of standards, the way we'd recommend doing that is not really to edit these ones that are in the installation, because these will get deleted if you uninstall the software, and they also will get updated, right? As I said, we may overwrite accidentally some of your own stuff. So if you want to build your own library of constructions, the place where you should put them is under users, your username, app data, roaming, Ladybug tools, and then standards. And you can see here, right, you have that same actually folder structure that we had before. And right in here, you can find constructions. If you drag and drop JSON files here of constructions or materials, they'll show up in your library. You can also drag and drop IDF files of constructions or materials. I know, like, for example, LBNL window can export IDF files. You can just drop them into this folder and they'll automatically get loaded up when you load up Rhino and the Pollination Rhino plugin into your library of standards. And so, yeah, so if you're looking to kind of create a reusable set of standards that you can use from project to project or share with other people in your office, this is the place where you should put all that stuff. And yeah, we'll probably in the future add more commands for zipping and sharing these files with other people and making it easier to collaborate with them. But if you put them in here for now, know this is where we have plans, to basically, to improve support for making it easy to share those libraries of constructions and build up these libraries for yourself. Yeah, good question.
Great, thanks.
Yeah, awesome. So
when you viewed the face properties, where were you able to set the units? For example, when you look at performance.
Yeah, so if you go under settings under the pollination tab, and then you'll see there's a little drop down here for units. You can use this basically to say what default units you want to use for length or area or volume, right? And so I just did presets for IP, and that switched them all over to IP. I mean, actually, you know, I find even in the US these days, we don't use pure IP. Like, for example, I know we use like watts per square foot a lot of the time. Yeah, here we go, which is like a mismatch of, I guess we don't even have like BTU per square foot here, do we, in power density as an option? But I guess, well, we have BTU hour as like as the unit here. In any event, right? Like, I mean, you can change these. We have each of these has a few different options for your preferred units. You know, I guess, right, for example, actually, we still use lux here, but foot candles, I know. We should probably add that as an option at some point, but that's how you can globally change the units for all this. So if I want to go back to metric, I can just set the default SI preset, hit OK. Right, next time I go back over to check the R value, right, this is going to be in meters per Kelvin per watt, meter Kelvin per watt. So yeah, so that's how you do that. Just use the presets here to change your units.
Just whilst you're in metric, Chris,
Yeah.
if you just look at, if you filter it by energy U value, do you get strange numbers? I get some very strange numbers.
Yeah, so are you looking at U value or U factor?
U value. I was looking at
Yeah,
U
so
factor.
U value, I'm
Oh,
sure you'll
okay.
get some ones that are, well, I mean, some of these
Oh.
are really high. Like,
I was going to say mine actually goes up to 166. I don't know why.
yeah, I bet if I mean, you know, oh, here we go. Actually, yeah, here's 166 actually in the yellow here. I'm sure that's for the interior glass door or something like that. So granted, I realize this is a naming convention that we kind of decided in Ladybug tools and pollination that isn't necessarily universal, but when we say U value, what we're basically referring to is the actual multiplicative inverse of the R value. So this means that there are no air films at all in the calculation of U value, right? And more often than not, especially when you're using with Windows, like right when you're looking at window constructions, usually manufacturers are going to give you the actual thermal resistance or thermal transmittance with the air films accounted for. So if you want the air films to be accounted for, you can use this U factor. Right, so whenever you see the word factor, either R factor or U factor in our software, that means that we're trying to put in air films on this. And if you use this right, I don't see anything with 160 values anymore. All of this should be under 6 watts per meter squared Kelvin. And so you're right. So that's basically right. If you want to actually like the ones that you're getting from, if you're going to compare with what you get from the product manager, you should use the U factor probably to compare those.
So sorry, just on that logic then. So the R value doesn't have RSI, RSO, as in doesn't have the boundary air conditions in that number.
Yes, exactly. Right. R value does not have that. And, you know, maybe we should actually add R factor if people really wanted that here too, because we just have U value and U factor. I know, yeah, in the US at least, I know usually all R value just tends to be exclusively used for opaque wall assemblies, and it does not include the air films. Whereas U value is what's used for the Windows. Your U factor, I'm sorry, is what's used for Windows, and that includes the air films. But that's basically right. If you see the word just R value or U value, that means there's no air films.
That's great. Thanks.
Yeah, no problem. Awesome. Yeah, I mean, and yeah, the solar heat gain coefficient here also, like, I mean, yeah, that like for this also we do a whole calculation in the background to make sure we account for both the directly transmitted solar energy as well as the heat, you know, solar energy that's absorbed by the glass and then conducts to the interior. So yeah, and you can actually see if you only cared about the actually directly transmitted solar part of it, right? This solar transmittance is what will tell you that. So yeah, there are kind of some nuances to the terms that we use here, but it's yeah, once you get them down, it makes it very easy to QA/QC stuff. All right. Any other construction questions before we move on to schedules and loads and some of the other energy properties?
I had a small question, and basically, assuming you define your wall, where can you manage the thickness of layers, or you know, the order of layers of your walls?
Yeah, so if you did want to build your own constructions, I mean, so there are interfaces for making your own constructions. If you type energy constructions, you can build up your own constructions. Basically, you see all the ones that we ship with Ladybug tools here, right? These are basically what's being referenced in those construction sets. but you could always create, add a new one, add either a new opaque or window or shade construction or air boundary. But right, if you want to create your own office spaces of design, right, you can call this, I don't know, Adobe Mass Wall. So we have menus for all this stuff. Granted, like a lot of the times I find myself mostly just using the the ones that we shipped with Ladybug tools, or maybe if I need to just overwrite one of them, I'll do that. But we give you menus to create everything from scratch if you want. And I don't know, maybe there's like a concrete material, like a heavyweight concrete material I can use to represent Adobe in this case. Or I can try and create my own new material, although I guess that's usually in a different menu, and then I'd have to add that. But but we have menus for creating all of this stuff from scratch. And once you create that material, right, you can either either build up, go to the PO energy constructions. Oops, sorry. Get out of this. Go to PO energy construction sets, and you can build up your own construction set from, maybe starting from one of these default ones that you can duplicate it. Like if I want to start with like the basis of design here as the, the climate zone 5, climate zone 4, steel framed, I can go and duplicate this and make a, I don't know, we can call it BOD for basis of design, right? And you can see we have all those wall sets here. I can then replace this wall set with, some other, wall construction that I've added in my library here, right? And I can build up my own construction set and assign that basically. So there are workflows for doing all this. I don't want to dive too deep into these details because we have like a lot of tutorial materials on this. And yeah, I teach whole workshops just on the, building your own energy properties and stuff. But yeah, for now, just know that, those menus that say like energy construction sets, that's the way to do that. And you can always apply them to your rooms by going to and selecting them, right clicking and saying edit properties and selecting that construction set that you created.
Sorry, I know you want to move on. Just one last question. When you create your own sets, where do they live file-wise?
So those get saved into the Rhino document with the model for now. Right. So you can build up
purely
your
with
model.
the model.
Yes, purely with the model. In the future, I think we'll also add workflows that you can take, those construction sets from the model and put them into, into your personal library of standards here that loads up every time, you basically load the plugin. But for now, right, we just have them live with the model, right? And so, yeah.
So in the meantime, though, we could just text bash that out of the HB.json file to make constructions into that area.
So if you have your own constructions that you've created, like in the Grasshopper plugin or something like this, or in in the HB.json, you could just drag and drop that JSON file into the construction folder. Or you basically, you just write those JSONs into the construction folder and they should load up. I can give an example of that maybe later if we.
I think this is something that we heard now like 2-3 times during just this workshop. So I wrote it down to do a better job. This is an item too.
And I should say, we have like some nice UIs for building. It's much better than trying to build a lot of these things in Grasshopper. If you look at our schedules, the way that you can create schedules, like your own schedule, you can basically build up, you select the type limits, and then let's see, I usually use fractional values from 0 to 1, right? And you can basically, if you guys have ever worked in OpenStudio, this probably looks pretty familiar, right? You can create your own schedules, to be whatever you want, basically from custom sets of rules. It's much better than try to build them up from lists of values in Grasshopper, for sure. At least more elegant and quicker, I'd say. But in any event, all right. So let me move on. Actually, now that we actually started getting into schedules, maybe we'll try and check what the schedules that we've actually assigned to these to our model here are. And so if I go over to this menu here now, right next to the color by face property, you can see there's a similar button that's called color by room property. So using this, you can see that there are actually a bunch of properties that you can assign on the room level that aren't just to the individual faces. And for example, one of those is the construction set, right? And you can actually see that this construction set for the 2019 Climate Zone 4, this is something that is assigned to all the rooms on the room level that's then dictating the individual face constructions. But there are more properties too. If I were, for example, to look at the program, right, and you can see right now there is no program assigned to this model, which is the default. Right, and basically that means there's no electric equipment assigned, right, and everything is 0. There is no lighting, right? So this is basically not a model that is ready to simulate yet, or at least it's not a realistic representation of an office or residence or anything right now. So what I'm going to do right now is I'm going to use basically another like kind of compound object that we have in Ladybug tools called a program type to assign all of these assumptions for lighting and equipment and everything all together. And to give you a snapshot of like what a program type looks like in, in the abstract, right? Programs are kind of composed of different definitions for people, lighting, equipment, gas equipment, infiltration, ventilation, set points. And each of those, right, for people, for example, you have the people density and people per area, and you have schedules that dictate that when people are in the space versus not in the space. You have a schedule for how active those people are, whether they're exercising or sitting on the couch or teaching a workshop, right? So all these definitions can come together into a single program object that says, basically, this is how this room is used. And just like construction sets, we ship Pollination and Ladybug tools with a bunch of default program types that we try and make it very easy to start if you just want to have some reasonable assumptions for these things. So I'm going to now try and set the program for all of the rooms in this model here. I'm going to select everything again just by selecting the top one, holding down Shift, and then selecting the bottom one. I'm going to right click here to go to Edit Properties. And then you'll see right under the construction set, there's actually an option here to select a program type. So I'm going to check this unoccupied, no loads, which is the default one that we've seen here. And if I click on this little none button, it'll bring up a menu with all those program types that we ship with Ladybug tools by default. And this will also include any custom program types that you've put in that user standards folder. And you can see, I think there are over like 1,000. There are almost like 2,000 different program types that we ship here, all for different building types and for different versions of the building energy code. Because, I mean, if you imagine the lighting that we used 10 years ago was mostly incandescent, right? So that's going to be a different lighting power density than the lights that we put in the building today. So I'm going to just select the latest building code again, this 2019 program type. And you can see we have all sorts of building types underneath this. We have courthouse or full service restaurant or high-rise apartment and hospitals, like all these different programs just for the latest building code. Maybe we'll model this one as a small office right now. And you can see if I just select small office, right, there are a bunch of different individual room programs depending upon whether it's a closed office or an open office or a dining or electrical mechanical room or a corridor or conference room, right? There are all these different types. Maybe right now I'll just select open office to assign to all these ones right now. And I'll hit OK, right? And you can see, right, the program type will change from unoccupied no loads to small office, open office. I'll hit OK, right? And we'll see now the electric lighting power density should probably change, right? At least it's not 0 anymore. We can see, well, the legend hasn't quite updated, but the max value is telling us that basically all the rooms now have a lighting power density of 6.5. And if I were to go probably over to the, I mean, you can see probably the lighting schedule too. Let me see, or sorry, this is lighting density still. If I go to lighting schedule down here, right, you can see there's an office small building lighting schedule, right, that is dictating when the lights come on and off. Right, and let's see, I mean, you could, if I were really serious about this, I'd assign a few different program types to the different rooms. I don't know, maybe you don't have to worry about following along with this, but maybe I'll just quickly select like the bathrooms here, master bath, and I don't know, there's 4 bathrooms in this model. And I can go to edit properties and I will change the program type to be 2019 small office. And then I'll set this to be a restroom, right? So I can hit OK, right? And you can see the schedule is all still the same between these two ones. But if I look at the lighting power density, actually the lighting power density isn't really that different either. Maybe the electric equipment, that should be different. Maybe this legend still isn't updating. Let me go and make sure that the maximum, yeah, okay. Let me make sure the maximum value of this legend is, maybe we'll set it to 10. Yeah, there we go. That's showing you what I mean. So, right, so again, you may need to double click on the legend to make sure that it's, previewing the way that you want it to. But right, this allows you to really quickly see, right, those restrooms have a different lighting power density than the rest of the rooms and, the rest of the open offices in the model. And if I were to like, let's say, take the hallways, I don't know, we have like 2 halls in here. And yeah, let's say I were to make those a different program type of 2019 small office. Oops, I didn't do a double colon. Small office, we'll do the corridor, for example. I can hit OK, right? And this will update, and we can see, I guess the corridors have roughly the same like lighting power density as the bathrooms. Maybe if we were to do a storage space, I'm sure that should have a really low lighting power density. Oh, I selected the wrong one here. But if I were to select linen, shafts, mechanical, and I don't know. I mean, again, you don't worry about following along with this. This is just, I want you just guys to be aware though that, right, that you can very quickly make something that is reasonable by just using the programs that we ship with the Pollination Rhino plugin here. Open, did I not do this correctly again? 2019, small office, right? Office, and then we will select the storage. Here we go. Yeah, right. So this just gives you a sense, right? You can see there's very, very low lighting power density in the storage. There's some lights in the restrooms and corridors, but most of the lighting power is in the open office spaces here. Right. So again, we try to make it easy to start. Like you can imagine if you're doing like an energy model, you might want to check everything down to these individual schedule values, but these will at least give you reasonable defaults for quickly making your models so that you can at least maybe get some informed decisions coming out of your models more quickly than usual with this. All right, any questions on either on these loads, basically, like, like people per area and the schedules and the program types in general? Any questions before we move on?
Chris, just a note that you have 14 minutes.
Yeah, I know. Yeah. All right, we'll go really quickly here. So I'm gonna try and like show you guys just a few last things here. And so don't worry about following along on this part. The last thing that I really want to do just to make this a fully simulatable energy model, I'm going to select these rooms and just add an HVAC system to them, because by default they're all unconditioned, and you could check that too within these QA/QC menus. And you can see you can always use an ideal layer system, right, which is just going to tell you the heat to be added or removed from the space. But we have a bunch of template systems that make it very quick to say that if like there's going to be a variable air volume system, for example, applied in your building, right, that you could build something that roughly aligns with those assumptions pretty quickly. And those templates are all part of this Open Studio library. You can see we have like categories, major categories of HVAC systems, whether they do all the heating, cooling, and ventilation with air, whether they do heating, cooling separately from the ventilation, and the ventilation is done with a dedicated outdoor air system or a DOAS. I mean, most of the baseline systems are all air like this, so I'll just select this for now. Maybe, we have all the baseline energy code systems here for a typical building. For one this size, it would probably be a packaged single zone or packaged rooftop air conditioner. Maybe for now, I'll pick this PVAV because I think it's a little bit of a better, or at least, it's a bit more representative, at least, of these different zones that we have in this model. And we have a bunch of different options within this, right? Whether it's a boiler or a heat pump. Like, I mean, those of you who know HVAC will probably, these terms will have meaning for you. Maybe I'll just select it with a boiler right now. And I'll make sure that we have some type of economizer that mixes in cool outdoor air when the space needs cooling and the outdoor air is actually cooler. But if I just hit OK, right, this will make an actual template system here that I can then apply to all my rooms, right? It'll say instead of being unconditioned, I now have this HVAC system assigned to it. I'll hit OK. And I can check, if I do want to do diligence, I can check the HVAC system right by coloring everything here, right? Everything's a packaged air variable air volume system. Maybe I might want to leave some spaces unconditioned, like the storage. I imagine those usually aren't conditioned, but this is good enough for now. I think we finally have a model that would be a decent representation to inform a design process in this case. So I'm going to just open up Grasshopper and just show you very quickly some simulations with some of the Grasshopper scripts that I gave you guys in the Google Drive here. All right, so you can see there's a whole Grasshopper subfolder here. And the kind of beauty of building your model this way with the Pollination Rhino plugin, because a lot of people will come to me and ask like, well, I could do all this energy modeling building process in Grasshopper for free with the Grasshopper plugin. Why do I really need the Rhino plugin? And and to answer that question, I'll just open up this Grasshopper file right now to show you what it would have been like if you had built this entire model using using the Grasshopper plugin. So in this case, right, I have, oh man, this is what it would look like. Not only is it a lot of components to bring together to build a model that's like this with just 15 zones, right? I needed to separate things by different programs in order to assign those differently. I'm getting all sorts of issues where the room volume is not closed within the tolerance, which I don't know why. I get an issue here where these apertures weren't matched to any parent face. Right, so I mean, the thing is, like, you can go and debug these in Grasshopper, but it's just so much easier with the commands that I showed you, like with the PO validate command, right, that you can instantly figure out these problems and fix these problems much more quickly than you could in Grasshopper. And this isn't to say that you couldn't with enough effort build it in Grasshopper. It's just to say that, right, if time is of the essence, right, just it's much easier to just buy a Pollination Rhino license, and it'll get you there a lot quicker. Right, and the thing is, some of these issues you also may not be realize that they're issues until you try and go and simulate it, and then you get an error, right, where it can't actually change the model to be. Yeah, I guess it's probably because the model units are in feet, and this was built in a different unit system. That's another nice thing, is that those two are always tied together in the Rhino plugin. But all right, let's actually say, if we actually now want to, let's say I really like the way I'm doing post-processing in Grasshopper, right? I have a way that I like to calculate EUI in Grasshopper, and a certain way of bringing in results to plot them on like an hourly plot in this case. Right, and I want to use this with my pollination model. Well, we tried to make this very easy and straightforward to do this. Right, we have actually, if you have the Pollination Rhino plugin installed, you automatically get the Pollination Grasshopper plugin. And you can see that this comes with a whole bunch of other components that let you basically import your model from the Rhino plugin into Grasshopper, so that you can work with it with all the same Grasshopper components that you may be used to at this point. So in this case, right, if I want to bring in this entire model that I built in Rhino here and actually simulate it in Grasshopper, I can use this PO model component here, just drop this on the canvas. You see, it's very much like all the other native Grasshopper parameter components, except now you can right click on this component. And if you have a model in the pollination model in the Rhino scene, all that you need to do is just say get model. And this will bring the entire model with all of the geometry, all of the energy properties that you assign to it, right? All those construction sets are coming through in this one single parameter component here. Right, and actually out of this component, whoops, I meant to pull up a panel. Right, out of this component, we're getting a model object, which is the exact same thing that you'd get if you had built your model from scratch in Grasshopper to begin with. So the nice thing about this is, right, I can connect this up to my script that I have here that, just simulates the model in OpenStudio Energy Plus and pulls in these particular results that I care about here, and uses my special simulation parameters that I know will be fast and quick to run this type of simulation. So, right, so I can set this true to just, basically I can now have a reusable Grasshopper script that I can use, anytime I want to run an energy simulation on a specific pollination model, right? All I have to do is just get that model from the Rhino plugin, right? And the same script can be used across multiple times. And that, not only does that make things a lot easier, right? There's a lot less debugging you're doing in Grasshopper, right? It also means that instead of, you don't have super custom Grasshopper scripts that are only applicable to that one project, right? Now you actually have something that is much more generic. Anytime you care about looking at energy use, right? In this case, I want to check the EUI. And in this case, it is 78 or so kBTU per square foot, right? I can use this on any model I've built with the Pollination Model Rhino plugin, right? And I can build up my own library of reusable Grasshopper definitions instead of actually like building a custom Grasshopper definition for every single project. Right, and we can see here the script is also making a 3D plot, right? All the capabilities that you like with the the Grasshopper plugin, you could still do those all, right? You can build your custom post-processing scripts to see things like this is the hourly cooling and the hourly heating that I got with this particular model, right? And let's say, for example, like this is great that we've been able to look at the energy use this way and get the EUI, but probably the next question that I would have is, okay, if the EUI is 78 kBTU per square foot, by the way, I think this is very high for a new building, for a new office like this, right? My next question would be, well, why is this energy use the way that it is? And instead of trying to like drop more Grasshopper components into the script and make it a mess, I can just grab my Grasshopper script that I use to basically answer this question for myself, why is the energy use the way that it is? I have a little second Grasshopper script here called evaluate annual load. I can just open this up. All right, and you can see that this is a Grasshopper script, or a reusable Grasshopper script that just can tell you basically the annual load balance on any particular room, and it plots it nicely on this monthly chart here. And so the nice thing is that what this will allow me to do is that let's see. Let's say I just want to understand what is the load balance of this particular room right here. What I can do, I can right click on this PO room component, right? This is one of those other parameter components here, just like the PO model. I can say set one room, I could select the room, and then I can go and I can double click this to true to run this component, right? And it will spit out for me these monthly charts. It only takes about a second or so. And I can take a look at the actual full load balance of this room in this case, right? And I can see there's a lot of heating and cooling, right? The reason why the EY is so high in this particular space, at least, is because there's a lot of heating and cooling load. And does anybody, I mean, if some of you have seen load balances before, right? This chart down here, right, is telling me that the energy that goes into the building has to equal the energy that goes out of the building. And so could someone then say to me, like in this case, why is the cooling energy use so high in this particular space of this model? What is the term of the energy balance that is driving this cooling energy use to be so high?
Solar gains.
Yeah, exactly, right? Almost all of the heat going into the space at this point, right, is all this solar term, right, which corresponds to this color down here. And it kind of makes sense, right, when we look at this space that we're modeling here, right? It's got a lot of windows. So we can see if we wanted to make a suggestion to the design team, maybe I'll just turn this to be like this, right? We can see tons and tons of windows in this space, right? If we're going to make a suggestion to the design team about how to lower the UI for this particular space, right, a big suggestion would be to lower the glazing ratio, or put some shading, or lower the solar heat gain coefficient. But right, actually the solar gain would also help us probably with this heating load, because if we see why is the heating load so high in this case, right? What is the big terms that are driving the heating load?
Heat loss from windows.
Yeah, heat loss from windows, exactly. It's conduction out of those really low U factor windows in this case, right? As well as infiltration is up there too, right? That's this mint green color in this case. All right, you can really quickly, right, have a dedicated script for just debugging this case. And right, I can easily do this for different types of spaces, right? Because not all energy balances are created equal for all spaces. If I were to look at, let's say, this, this bathroom in this case, right? I could rerun the script and we can see the load balance is a little different in this case, right? It's much more infiltration driven. Or I could select multiple rooms and look at this all together in this case, right? I can right click here, set multiple rooms, and I can do an entire load balance of the whole building. Right, and this will only take about 10 seconds because this is a kind of optimized script for producing these things. But yeah,
Sorry.
but let's say, yeah, question.
Sorry, Chris, I was just going to ask, whilst you're doing that, are you actually just simulating one zone?
Yes, and actually, and so that's just because this component has some logic in it for the interior cases. It'll just automatically replace those with adiabatic boundary conditions, so you can get a view of just the load balance in that room.
Right.
Yeah, but if you select all of them together, it will actually model the heat flow in between spaces correctly, such that you can see right over the whole building. It's still the solar gain is the big reason why we have the cooling load, and yeah, in this case, still the glazing conduction is a big reason why we have the heating load. But yes, before when I was selecting individual rooms, right, it was just on a room by room basis. So I know maybe I should ask everybody here, like there were a couple of other Grasshopper scripts that I want to show you. Is everyone all right if we run over maybe by like 10 minutes or so? I could also maybe just, say if you guys need to leave, no hard feelings. I'm sure you guys may have other meetings and stuff to go on, but it's been a pleasure teaching you all.
Yeah, and I don't know if the meeting thing, the Zoom will stop. I don't know how.
Yeah, I haven't seen anything, at least as the organizer, that has showed up to say that it would stop. So I think we could probably keep going.
Maybe I think like for the sake of everyone, and I know like we have from different time zones. Do you have you have closing slides too, right?
Yeah, I mean, all right. Yeah, maybe I should go to those and just wrap everything up here. All right, but maybe if I have time and people want to stay on, we can definitely.
Yeah, I think we can officially end the thing, and then you can continue.
And then fair enough. That's a good way to do it.
With the longer version.
Right.
Yeah, and are you going to show any apps? Just a question.
I guess so. I
Yeah,
wasn't
maybe.
necessarily planning on it,
So,
but we could do it really
yeah,
quickly right
I
now.
mean, a really quick one. If you go to apps, I actually
Yeah.
built an app for what Victor asked for. So if you go down all the way down.
Oh, for what? Oh, okay. Because I was gonna load up, like, for example, yeah. I mean, so apps, by the way, if you guys weren't here for the morning session, this is a beta feature that we're currently working on, but it's the future of where we're heading towards. And basically the idea would be that, you wouldn't, if you have people, especially in your office, who don't know Grasshopper, apps will be much more accessible because you can essentially build your own apps to have a lot of these functionalities of the core libraries, but just in something that's deployed basically to this apps interface here. So I'm sorry, it's still launching.
So you
this one
can
right
add
now.
a plus. You can add that plus stuff.
Oh, add that, right? You can
Yeah,
actually have
and then
multiple apps open at once here.
all
So
the way
if I-
down because it's not Ladybug tools app. Just scroll down.
Oh, okay. You can see we already have a
And
bunch here.
yeah, rename face by room name.
Yep. Okay.
So Victor, this is basically, I mean, this is the very first version, and this is like what it does is basically what you asked for. So it does get the model, and yeah. So and then changes all the thing, and you can download a new one. I mean, ideally, at some point, we want to have a feature that basically pushes this back into Rhino. But now, if Chris opens this new one,
I guess, yeah, I
new
can open it
Rhino.
in a new Rhino instance. Yeah. Yeah. So, I mean, the idea with the apps is kind of, I mean, yeah, basically anything that you do in Grasshopper, you can put it into a very nice web form UI and basically deploy it to your office so that many more people can make use of it than just the Grasshopper nerds. Right. Yeah. I guess in this case, you were seeing that the faces get renamed. Oh,
Yeah,
nice.
so it's
Yeah.
named
Very
based
cool.
on the thing and then the orientation. I
Yeah,
mean,
very cool.
here is the source code if you want to go change it and make your own thing.
Yeah.
But this is basically the promise that, and we just say everything can be an app, and we can do it quickly. I just said, okay, let's at least for this one we build an app.
Yeah.
The
So for
background.
example, right, if you want to get a load balance, right, and someone didn't know Grasshopper, didn't know how to open up that script, we have an app for annual loads that does actually the energy plus simulation and everything, and will spit out actually a nice plotly graph of the load balance. Right, and these are using the same core libraries, right, the same things that we use in the Grasshopper plugin, but right, this is packaged in a much nicer way. Right, and you can give like tables for like summaries of heating and cooling, right? You get the the load balance here. You could make them full screen, or what is it? No, that's the pan button. But right, these are hoverable over. Right, you get the you can turn this build apps so you can easily convert into IP if your office is doing that more than other stuff. Right, so yeah, right, so that's the promise of apps. That's where we're going. Again, the apps are kind of beta right now, and so I mean, a lot of the times if we need to fix a problem quickly, we'll do it in Grasshopper first. And chances are, right, if you mock things up in Grasshopper, you'll be able to turn that into an app eventually when we have when apps are finally out of beta and we have like full support for them. Yeah, but that's the vision of where we're going for with this. I mean, I guess, yeah, I can wrap up and just summarize here that, right, that the real advantages of the Rhino plugin, right, instead of building everything with the Ladybug Tools plugin and having tough time QA, QCing stuff, right, it's much easier, hopefully, with the commands that I showed you to just preview, get a view of everything that's assigned to the model, fix the model really quickly, zooming in. This is, I mean, a lot of the models we work with are not these 15 zone models. They're big things like what you see on my screen here. This is like a 500 zone NREL building, I think, the NREL headquarters in Chicago or in Colorado. Right. So yeah. So I mean, the idea is that you can actually zoom in and out of scales and actually build these large models that are very tough to construct with just the Grasshopper plugin alone. And then the Grasshopper plugin can take on the role of, right, of being like, kind of just the useful thing. You can have multiple reusable scripts instead of just having, one big custom Grasshopper definition with spaghetti, hundreds of components, like what I see people upload on our forum all the time. All right, it's like, this is the difference, right, before and after of working with the Rhino plugin. And so, right, that, instead of having one big script that does all this together, right, you have the reusable scripts that you can share with people. And be able to come back to it and not have to change a bunch of things every single time. I think we covered most of this stuff, like with the, all these things that I have in the wrap up presentation here. But just to summarize, right, the real big advantages, the real QA QC tools that we have, the validation command, like it does a lot more stuff than I was able to show you in just this workshop, right? It will find things like non-planar faces that you see here. Anything that would make it unsimulatable, you can find with just this one command, which is really useful. Right, you can build these complex models with ease and zoom in out of scale with the Rhino plugin. Right, you can resolve these errors before they slow you down. Right, these things. This is showing you what that check geometry adjacency command would do. Specifically in this case, right, you have two rooms that are right next to each other that should be touching but aren't. Right, but you can use this command and then the native Rhino move edge to in order to align everything and make sure that it's correct. Right, you have this align to grid command that I showed you that allows you to take, something like this, which is very typical from a Revit export, and snap it all together, right, to make sure it's nice and clean and everything's touching everything else as it should be. Right, and the one thing that we didn't really get to show you in this one, which is kind of still a beta feature, I should say, but we have a command called PO sync models that helps a lot with this particular problem that I'm sure many of you are familiar with, the 2-week turnaround problem, where you have a design team and you have an energy modeling team that are meant to coordinate with one another. And the design team has an original analytical model that it gives over to the energy modeling team. And the energy modeling team may clean that up with pollination, add constructions and start adding schedules and programs and everything to it, like what I showed you here. But as they're doing that, right, the design team isn't just sitting around doing nothing, right? They're probably continuing the design process. So you'll usually have a new iteration of the design project while you're adding all these programs and constructions and getting the model right. And so we have a sync model command, a PO sync model command that is meant to try and take an updated geometry model from the design team and take the metadata that you may have from your schedules and programs and constructions, and basically using the IDs of the rooms, match those back to one another to give you a new updated model. So, right, so as I said, this command is kind of in beta right now. We're going to be actually probably working on this in the hackathon. So if you guys, if you see Mingbo, Mustafa, and I there, we'll probably be working on a new updated version of this. But we want to be able to keep up with the design process. We understand, that designs are not static, right? It's not like the design just ends when you start building the energy model. And we want to keep things in sync so that as new iterations happen, right, we can constantly inform the design process. Right, and so to give you like a video, at least to show how we prove the concept, right, this is that PO sync model command. And in this case, right, we're trying to sync energy metadata into an updated geometry model that we have here, right? And we sync in that model, it'll tell you, we'll validate it on the beginning. It'll show you all the rooms that have changed or been updated, right? And you can say, I don't want to bring in the geometry, I just want to bring the metadata, and you just merge that into your new model. Right, this is and then you have all those programs assigned to the rooms like that. Right, so that's the idea with that. You can also do the other way of syncing design changes into an analytical model, but I think you guys got the picture of that from the previous one, so maybe I'll just go to the next one. I'll also say, right, we have all these different formats that you can export your pollination model to once you get into this nice cleaned up state. Right, you could go to OSM or Energy Plus or Radiance with our native Ladybug Tools ecosystem, or you can, export it to IES if your modeling team is mostly using that to build the energy model. We have GBXML, which is at least the best way to get into DesignBuilder right now. We have an IMP format to export to eQuest, and you can see this is what that IMP looks like, the 600 room pollination model exported to it. Right, so this is a workflows that we're kind of committed to making, a big part of the ecosystem here. Right, and so. Right, and this is just kind of showing you can also export gem from IES and bring it back into pollination. I think Mustafa already showed you this morning, so I won't dwell too much on it here. Maybe the eQuest export. I think you guys get the picture of that too with the screenshot. But I'll just say, right, this philosophy that we have here, right, is that, and what really differentiates us, I think, more than a lot of the other softwares out there, is that we are very much so interested in building the connections and the workflows between tools. More so than any other, I think, energy modeling software that's out there. And the way that I'll kind of like summarize here is that, historically, like a lot of us have been told that there are only really two ways of working with software. Either you have like this disconnected set of tools, right, where you have to pass back and forth DWGs and PDFs and docs and CSVs to get things coordinated between your software, or you have this one tool to rule them all, like a BIM model that can only export to other interfaces but can't necessarily receive data back into it, the centralized tool. And right, in these two ways of working both fall short, I think, of like the real potential of what we would ideally like to work with in our software here, because even something like this with the BIM model, right, even though these designs are connected to one another, the fact that I can't update my energy model until I've changed all the details in my BIM model, right, this is something that can slow down the iterative process of design and iteration. So, right, so if neither of these philosophies reach the full potential of computational design, and both of them are kind of focusing on individual tools themselves as a solution, right? Our take on this is that instead of having a singular tool to solve your problem, right, we're not selling you just one singular well-crafted hammer, right? Because hammers are great as long as all your problems are the same, as long as all your problems are a nail. But suppose you have a problem that is different, that is a screw, you may be screwed, to put it not so lightly, but right, and you can try and use the hammer, right, to try and fix a situation. But our philosophy is, right, what you really want for this case is a tool kit, right? Use the right tool for the right thing. Use Grasshopper what it's best at. Use Rhino what it's best at, right? And you could fluidly move between these two. So if I had to say, like, how we infuse this philosophy in all of our tools, well, certainly this is a part of the Ladybug tools, historically. The fact that you have individual components, each of which is like its own tool in a kit, right? In the same way that you have a workflow with your power tools that you string together in a workflow to build a piece of furniture, right? You string together those components to make custom tools. Right, but this philosophy also goes further than that, right? There, you have a kit of tools, your pollination commands that you guys have learned in this workshop here, right? We've, right, and you string these together to clean up your model and to build your custom workflows, right? That this is all meant to be, the toolkit philosophy. And if we had to say what really differentiates a toolkit from either of these two philosophies here, it's that instead of focusing on individual tools of the connection, right, we focus on these workflows and interconnections much more so than the individual tools themselves. So if there's one thing I want you guys to take away from the workshop today, it's that, that is what really the Rhino plugin is meant to be. It's not meant to be an island, right? It's about this connection to all these other platforms, right? It's about the connection to Ladybug tools and all these other simulation engines that we built here. It's about the connection to all these other simulation softwares and all these other file formats here. And it's about the connection to cloud and desktop computing, which we didn't even get to the chance to address. And it's about the connection of our community and our people to one another. So thank you guys all for sticking it out this late. Should I just answer some last questions? I think maybe that's the best way to wrap up. And if some people still want to see some Grasshopper definitions, I can show you those at the very end. But I can see actually, oh, wow, we already have some questions in the chat here.
Yeah, I think they covered most of the ones in the chat. So
okay.
Anyone else has any other question? Maybe you want to stop sharing the screen and.
Yeah, let's do it. Okay. So let me stop the screen share.
Thank you so much, Chris. I just wanted also like to give credits to like a few people for Rhino plugin. Of course, like everyone who helped us with feedback, but Niva, who is sitting here and doesn't talk much, is basically the force behind the Rhino plugin, being the Rhino plugin for the apps, and Tonello is really the person who did most of the magic. And Chris himself is the one who is keeping them all, like with all these core libraries together so things don't fall apart. So yeah, I wanted to thank you, all of you, and thank you for attending, but thank you, our team that make this really happen. It feels good for me to just like watch this workshop too. It's really nice. Yeah,
I mean, and we definitely have to thank everyone who, especially if you are a member of our forum and you've like posted issues or especially if you've posted design models that have helped us improve the plugin. We owe a lot of thanks to you too. I know Mustafa, you said that for the Revit plugin, but it's just as true for the Rhino plugin that a lot of these cases we wouldn't have nearly been able to make this as well as we've made it without all the models you've given us and all that.
And we should ask like a few people we have here that I remember have given us feedback that's already made the Rhino plugin better. Paul is here. Thank you so much. Victor has been really active. Levent has given us feedback for the Revit plugin at Rhino yet. Or he's working on that. So thanks all of you. And I hope you see like the feedback that you have given us, like how it has improved the product from where it was last year to where it is now. And honestly, like Victor was saying, like I have the version from 2 weeks ago. 2 weeks ago is really old, usually. But yeah, but we have learned not to break things. So the versions still work, but yeah, we're adding new features as we go. So any questions, comments?
Just want to thank you guys all again. That was really super.
Thank you, Ben. Thank you.
Really appreciate all your time and effort today.
Thank you, Ben.
Thank you so much. We have a question here. What is your plan for scaling LBT pollination training? Are you maintaining the LBT Academy or just the YouTube channel? So good question. One, probably you have seen that we are teaming up with ARPAN and Performance Network to do a Pollination Academy. So basically, we are going to work on training material in pollination. That's part of the early next year. For Ladybug Tools Academy, we have the Academy, which is paid, and it's the legacy version. And we have the YouTube channel, which is the new one, and it's free. Mainly, our idea is don't use the legacy. These are free. Just learn this. And like that paid, hopefully, like make more people to learn the new one. So the idea is to phase out the legacy and continue building more materials for the LBT ones during the upcoming year.
And in the meantime, also we are starting to offer workshops if you're
interested in that. Right. We didn't mention that. The two things that we have been doing, we started a program called what's called, not institutional,
enterprise
partnership. So if you are a large office and wanted to deploy this pollination stuff, Ben, can we continue?
Yes, absolutely.
Thank you.
Yeah.
Sure. So yeah, if you are a larger office, we started this enterprise partnership and we are already talking to a few offices. So the goal is we have seen offices like using all this stuff. They like writing apps, but either they don't have the internal resources or they don't have the expertise. Basically, the goal is like we come in, what will take you like 1.5 years, 2 years, we're going to do it in 6 months. And we'll get you where you want to be. That's one offering that we have down there. You can apply for here on this page. And we are now like looking for the partners for next year, 2023. The other one is workshops, like Chris said. We have started teaching workshops again now for pollination. And you know us, like we have done so many workshops, and this is another one. So like that, always like the feedback from workshops has been really good. And the difference between that workshop and this is we take the time to really customize it for what your office is interested to learn. As you see, like with all of these plugins, you can do way too many things, and we understand engineers are using them differently than architects. And now like we even understand engineers are using them differently in different parts of the world based on the like building code and like typical HVAC systems that they have and all those. Oh, there is another question.
Yeah, cloud computing. We didn't get to cover that.
Cloud computing. Sure. So, I mean, a good overview is on our website. Maybe can I share my screen? Maybe I can just walk you quickly.
Yeah. Is that multiple? Here we go. All participants can share.
Okay, let me share my screen. Unless Chris, you want to show.
I mean, I can show, but I think.
Oh, okay, no, it's fine. Yeah, okay, can you see my screen now?
Yes.
Yeah. So, I mean, the initial thing that when you think about cloud computing, of course, if you have large studies that you want to run, cloud is fast. That's like the easy one, right? Like you run stuff on cloud that are, larger studies, then it runs faster. But what comes more than that is If you use the cloud computing feature, or if you run the studies on cloud, this looks like, think about it like, I mean, if you are a GitHub user, you have a history of your code, that what are the changes that you have done. You kind of get a similar feel here, that you have a history of all the runs for different projects. So we have Ladybug Tools organization here. This is the demo project. You see, like, these are all the runs that people have done during the history of this project, which means, like, as an office, we can always come back and see, okay, for this project, what are the things that people are running? You can even write apps to parse them and say, this is the thing that people run the most, or this is the thing that's failing. The other good thing is a lot of this has a visualization. So if people run these studies, and then if you have a customer or client and you want to share the results with them, you can basically, instead of sending a Grasshopper file or whatever file that you want to send, you can send them the link to this viewer here, and they will see this. I mean, there are a few things we have to do better. For example, we need to make something to save the state, the exact state of the viewer, so you can see it. But I mean, I showed it in the morning for the Revit workshop, but you have, like, this is a full-fledged viewer with all the good things that we usually offer for making the simulation result meaningful. So you can use higher level, like minimum, mean, max. You can make things of, like, I just showed the thing, but you can also add this. Okay, I go a little bit higher. Can do this happiness here. What's it called? Section box. To make different section box. If you like the view that you're seeing, you can always, like, save them as a screenshot. This is all automated. And the good thing is we didn't talk about it, but you can include all these things in the app. That's something that we do in the workshop. So what we are trying to do is, like, making your studies reusable, not only for running them, but also for sharing them, for going back to them, for the thing that happens to me a lot, or happened to me a lot in my career, that you do something, you leave the office, and they get back to you in like 6 months or something, or you're still in the office, and they're like, you remember that project, the customer, it's something you ran, like, they came back, then we changed these 3 things. And the answer is usually, I was like, no, because I don't know where the files are. Because at the time that we ran, I don't know where the model was. Like, I don't even know who ran it. But here, you can always come back to those projects. Your simulation is always here on Pollination, unless you delete it. So that means you can recreate that, right? Inside Rhino, inside Grasshopper, everything, and change the things that you want. It feels like I want to call it like similar to what GitHub kind of is trying to do, but we're not really that good. But we are trying to, like, bring some of the good things about building like code development or software development to building simulation. So it's not anymore that people are running simulation on their computers that you have no idea what's going on. So I think the speed, collaboration are the main 2 advantages of cloud computing offering.
I was thinking about letting people monetize apps on Pollination.
Very good question. And like you guys did, I was in Swarm, right?
Yeah, we hinted at it with Swarm. We, like, never took a credit card, but, like, we put a cartoon price on the app, and, like, still, I did a presentation like a week ago, and somebody was like, I'd pay for one of those. But, like,
so
I think there's still there's some juice there to think about,
Right. There is a challenge with selling SaaS services in 2022, and that's dealing with taxes. So unlike any other thing that you sell, like, say, what do you call it? It doesn't depend where our office is. It depends where the customer is. So we can activate that, but that means we have to handle this very complicated process of, like, you're buying from whom and where from you're buying it. So what's the tax for that? It's very complicated for us. So the way we have been offering it, or people are doing it, is make a Pollination account, right? Organization. And one of the things that you can do, every app that we didn't show, is apps have version control and access control, right? So you can basically build a team for your customer, deploy the app to your own account as private, and then give them access to use the app. And then they charge you, they pay you basically as a contract for software development. This is very similar how we use GitHub. It's just complicated. Like it's possible. It's very complicated.
Awesome. Even that's great. You know, just like being able to do specific access control.
Yes, you can totally
invoice
do that.
them. That
Yeah.
work. Yeah.
That's the thing. And most of these offices actually like invoice at the end of the day. So yeah, you can build teams. And then based on the different teams, so let's say team consultant, I want to give them access to this sample direct something. So the thing is I can come here and then say team consultant, they have read access and they will get read access. I mean, this is meaningful if this is a private app. And to make the app private, you should pay. So I can pay for the app and now I can make it private. So now only Ladybug Tools owners can see this app and Ladybug Tools consultants. If that makes sense. So yeah, you can monetize it this way, but if it wants to go through OSTAT payment and tax and something, doesn't worth it, honestly, like for the amount of money that we're going to make. It's really complicated.
I think when we were first showing that swarm stuff, Scott Davidson kind of grabbed me by the arm. He was like, have you actually looked, or maybe it was Brian from McNeil, have you actually looked at selling stuff across, you know?
It's, yeah, we got hit really bad. It's like we are using Paddle, and we, of course, like everyone else, we started using Stripe, and then very late in the implementation, we realized Stripe basically collect the tax for you, but they don't submit it. That means like we will, or like, you know, someone from the government of Japan or India and something, and of course, until like this is big enough, they're not going to come after you. But at the same time, it's a tricky thing of like, why should I do that for a small amount of money maybe that I can make from that? So it's high risk. Just invoice people.
Thank you for sharing your thinking behind that. And experience is even better.
It's a bad experience. Like, we should talk about this more. That wasn't my proudest moment, but yeah, like this.
Hey, listen, we're all learning here.
Yeah.
That's what this whole deal is all about.
Yeah, just talk
together,
to me
right?
beforehand if you want to implement, if you want to sell SaaS online, talk to me like on what are the options. I'm not representing Paddle in any form, blah, 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 blah. But yeah. Any other questions? How do I stop here? Man, why I can't work with you? Yeah.
Thank you, guys.
Yeah. Thank you.
Thanks again, everybody. Thanks for everybody who bought a ticket. Everybody for your time. Stop me, Chris.
Thank you, everyone. I didn't do anything. Thank you so much. Thank you for showing up. Thank you for staying around. And again, thank you for everyone who has helped us so far, and keep them coming. We love comments. Don't worry at any point that maybe you have so many comments. If there are so many, basically we ignore them. Don't worry. Or we don't ignore them. We just chew them. I'm kidding. But like, never think like you have so many comments. We always look forward to hearing more about like, what do you want to be better? And as you saw, we use it on a daily basis for our consulting work. So making it better, first of all, is just like it's going to benefit ourselves too. So very happy to do that. We have several incentives to do that. So keep them coming. Okay, then I think we can wrap this up. Yeah, thank you, Ben.
Thanks.
We'll see you in a few days, people in New York.